Hello there and welcome to Just About Earth, where curiosity settles in beside you and ideas drift through at a pace that suits a quiet evening. This place has always been a small corner for winding down with something thoughtful, something steady, something that can sit with you as you rest. Tonight we're easing into a question that's been in the background of human imagination for a very long time. A question that arrives softly but lingers with weight. What if the world we know isn't the first world of its kind? What if the story of civilization didn't begin with us, but began long before, in an age erased so completely that we only feel its outline in the questions we can't quite answer? There's something strangely calming about thinking of our place in a long chain of unknowns. It doesn't need drama to pull you in, just an open space in the mind, the kind you get when the lights are low, when the day has let go of you a little, when you're finally free to wonder about things that don't demand anything in return. And this idea, the possibility that we might be a reset of something earlier, something older than our oldest ruins, tends to bring that kind of quiet curiosity. It's the sort of thought that doesn't rush. It doesn't need anything from you. It simply asks you to sit for a moment and look at humanity from a slightly different angle. Before we wander further into this, I'd love to know where you're listening from tonight. Not as a formality, but just as a gentle grounding. Sometimes knowing that there are people all over the world drifting into this same moment with you makes the whole experience feel a little warmer. Maybe you're tucked into bed, maybe you're on a couch, or lying on the floor with a pillow pulled close. Maybe you're listening in a kitchen with a small light on, or in a room that's finally quiet after a long day. And I wonder too, what time it is where you are. Late enough to yawn a little, early enough that the rest of the evening still stretches ahead, somewhere in between. Wherever you are in your own timeline, I'm grateful that you're here. If this kind of soft exploration is something you enjoy, it helps this little space a lot when you like the video or subscribe. It's an easy way to let algorithms know that quiet science and gentle curiosity deserve a place online. But you're not here for algorithms, and I won't linger on that. You're here for the question, for the slow pull of a what if that doesn't need an answer right away. So let's ease into the idea, not with grand claims, not with certainty, just a calm, steady walk through the possibility that we, with all our technology and all our progress, might not be the first to reach this point. Humans often picture our story as a straight line beginning in caves and leading to skyscrapers, satellites, medicine, electricity, and whatever comes next. But the Earth doesn't work in straight lines. The planet has been through cycles that have wiped out almost everything alive more than once. Oceans have risen and fallen, continents have broken apart and collided, entire ecosystems have grown, thrived, and vanished again. The surface of our world is not a permanent record. It's a constantly rewritten one. When you look at it that way, the question shifts from being strange to being quietly reasonable. If Earth has reset itself over and over for hundreds of millions of years, is it so impossible that some intelligent civilization might have risen long before humans ever walked the planet? Something that grew, advanced, reached its peak, and then disappeared so completely that only the faintest hints remain, buried so deeply or scattered so thoroughly that we don't recognize them for what they are. That doesn't mean it happened, it just means the idea isn't as far-fetched as it sounds. The Earth is very old, our species is not. But that's getting a little ahead of things. Before thinking about ancient resets or lost worlds or forgotten beginnings, it's comforting to pause with the simple fact that humans have always wondered about what came before. Every culture, every generation, every curious person who has ever stared at the stars or walked through an old ruin or felt something familiar in a landscape they've never visited has touched on this question in one way or another. Even before modern science, people imagined cycles of creation and destruction, myths told of worlds that rose and fell. Stories passed down through centuries carried the idea that what exists now might not be the first version of existence. We usually take those stories as imagination, as metaphor, as a way for ancient people to explain natural disasters or the feeling that the world is older than anyone can quite grasp. But stories, even when they're not literal, often come from real emotions. And the emotion behind these old cycles is something we still feel today. There's a quiet sense that humanity hasn't always been the centre of the timeline, that maybe the world has been old and full long before we ever arrived. This isn't about believing hidden civilizations built cities more advanced than ours. It's about taking a calm, steady look at the scale of planetary time. The Earth has held oceans for billions of years, forests for hundreds of millions, dinosaurs for longer than humans have existed by a factor we can barely picture. Entire species have lived fully realised histories, countless generations long, and left behind nothing more than fossils scattered through layers of stone. When you think about how thoroughly time can erase the record of life, it becomes easier to imagine how fragile our own evidence might be across geological scales. If humanity disappeared tomorrow, really disappeared, with no one left to maintain cities or power grids or archives, it wouldn't take long for the world to cover us up. A few centuries would turn buildings into ruins. A few millennia would erase almost everything but the largest stone structures. A few million years would scatter even those. Weather, erosion, tectonics, oceans, and life itself are remarkably efficient at cleaning up after us. So if an earlier civilization existed long before the dinosaurs, long before mammals, long before anything familiar to us, it's not unreasonable to think it could be entirely gone by now. Not just ruined, but erased so thoroughly that it blends into the geological record as if it were the environment itself. But I want to move slowly here, staying away from leaps or conclusions, and simply let the idea settle. This isn't a story about proof. It's a story about possibility, about the gentle space between what we know and what we don't. And most of what we think of as history is built on the thin layer of time that humans have occupied. That layer is shallow compared to the depth beneath it. Our oldest texts are a few thousand years old. Our oldest cities, perhaps 10,000. Our oldest clear-cut civilizations trace back maybe 12,000 years, depending on where you look and how you define them. That sounds like a lot until you compare it to the 4.5 billion years Earth has existed. If the planet were a book, human civilization would be a single line scribbled near the end of a very long page. Which leads back to the question, what if this isn't the first line? What if, somewhere deep in the pages before us, there was another, or several others, something capable of shaping the world in ways we no longer recognize? Maybe it used technologies that didn't leave behind metals or plastics, or the kinds of things we'd expect. Maybe it rose in a time when the climate was completely different. Maybe it belonged to a species we don't know because it left no direct descendants. Maybe it fell long before mammals evolved. We're not claiming these things. We're just letting the idea breathe. And in a way, the idea has a gentle comfort to it. It suggests that intelligence isn't a rare cosmic accident. It might be something the Earth attempts again and again. Something that emerges whenever the conditions are right. Something that grows, learns, builds, and maybe resets. Not in cycles meant to be dramatic or destructive, but in the natural rhythm of a changing planet. Thinking about this can make the world feel a little bigger, a little older, a little more mysterious in a calm and steady way. It can soften the edges of the everyday rush and remind you that humanity is part of something much larger than the span of our own lives. We're not floating alone on a tiny timeline. We're embedded in a planet that has carried countless stories, most of them lost, many of them unimaginable, all of them part of the same Earth. As we drift further into this thought, it becomes easier to imagine traces of earlier worlds hiding in plain sight. Not extravagant ruins or towering remnants, just small hints that make us pause. Strange geological formations that don't fit expectations, artifacts whose ages are difficult to pin down, gaps in our understanding of early human development. These are not evidence in themselves, they're simply reminders that our knowledge is still young, still filling in the blanks. But we'll get to those ideas soon. We're not in a rush tonight. This isn't a chase. It's a slow walk through layers of time, moving from the world we know into the world that might have been before. As this idea unfolds, there's something steadying about imagining humanity, not as the first chapter of civilization, but as one version in a longer series, a version that might be repeating patterns older than our species, older than our continents, older than the ecosystems we live in. There's a moment when you first consider the possibility that humanity might not be the first civilization to rise on this planet, where the mind doesn't know whether to lean forward in curiosity or simply settle into the idea as if it's something familiar. It doesn't feel like the shock of a sudden revelation. It feels more like opening a door you didn't realize you'd walked past 100 times. There's nothing loud about the idea, no sudden brightness. Just a quiet sense that this question has been waiting for someone to sit with it long enough to hear what it's been trying to say. Thinking about forgotten beginnings isn't about imagining dramatic ruins or hidden empires buried beneath continents. It's about the subtle things, the soft edges of possibility, the gentle awareness that Earth is so much older than our stories about it. When you consider that the surface of the planet has been rewritten by rivers, oceans, storms, volcanoes, shifting plates, and entire ages of life rising and fading away, it becomes almost strange to assume that nothing advanced ever existed before us. Not because we have proof that something did, but because time itself is so vast that our own presence barely registers on its scale. Most of us grow up with the feeling that human history is enormous, that our timeline stretches so far back it almost touches the beginning of the world. But when you place human civilization on the timeline of Earth, it becomes a thin thread at the very end of an enormous tapestry. And when you look at the rest of that tapestry, the parts stretching back hundreds of millions of years before us, there is silence. Not complete silence, of course. There are fossils, minerals, geological traces, but those aren't the stories of beings like us. Those are the stories of animals, forests, oceans, deserts, creatures with no cities or writing or tools. It's this vast, quiet space in Earth's history that makes people wonder if something could have existed there, something complex, something intelligent, something capable of shaping its environment in ways that have simply vanished through the normal processes of planetary change. It isn't a loud hypothesis. It's a whisper, a soft one, the kind that sits comfortably at the edge of imagination and reason. If you think about how easily the traces of our own civilization could disappear if given enough time, the idea becomes a little clearer. The tallest buildings and strongest structures we've made would eventually fall. Metal would rust away, concrete would crumble, plastic would break down much faster than we assume once sunlight, heat and microbes had their chance at it. After a few thousand years, only fragments would remain. After a few million, those fragments would be scattered, buried, compressed, or melted back into the earth. We like to think that our world is permanent because we see it every day, but permanence is a relative thing. Even the tallest mountain wears down grain by grain. Even the deep ocean floor gets recycled by tectonic activity. The planet is patient, much more patient than we are, and patience is the one thing needed to erase anything that once stood on its surface. People sometimes imagine we would easily detect any ancient civilization if it had existed. But what would we look for? If a species rose and fell 50 million years ago, there would be no pottery left, no glass, no intact tools, no bones on the surface, and even deep underground, the chances of finding recognizable remains would be incredibly small. The geological record is good at preserving certain kinds of things like shells or impressions of plants, but it's not good at preserving advanced material objects. Most objects made by an intelligent species, especially if they use materials we haven't even imagined, would either decay or be altered beyond recognition by the time we find them. Thinking about forgotten beginnings doesn't require believing in anything extraordinary. It simply asks us to consider scale. Our species, in its modern form, is around 300,000 years old. Agriculture is around 12,000 years old. Cities may be 8,000. Most of what we call civilization fits into a window so narrow that, compared to Earth's full age, it's thinner than the thickness of a single sheet of paper in a stack taller than a skyscraper. If you imagine Earth's history as a long, slow walk down a winding path, human existence appears only in the final few steps. Everything before that is a long, quiet stretch filled with ecosystems we barely understand, forests that rose and fell long before ours, oceans that covered lands we've never seen, continents that have drifted apart and crashed back together. Across these vast periods, life has changed its form many times, adapting to new environments, recovering from catastrophic events, reinventing itself again and again. In that long sequence, it isn't impossible to imagine that intelligence might have emerged more than once. The first whisper of this idea usually begins with small observations, a geological anomaly here or there, a structure that could be natural but feels slightly unusual, patterns in the fossil record that seem too orderly or too abrupt. But rather than jumping to conclusions, it's helpful to let these things sit quietly, as hints rather than evidence. Nature is capable of creating shapes and formations that look intentional even when they're not. And humans are very good at seeing patterns, even in randomness. So the point isn't to treat any single anomaly as proof of an ancient precursor. The point is to acknowledge how much we don't yet know. There are layers of the Earth we haven't explored fully, parts of the ocean floor that remain unmapped, regions buried under ice, sand, and volcanic rock that hold secrets from ages before ours. And then there are the parts we cannot access at all, because they've been recycled into the mantle or crushed beyond recognition. When you think about the limits of what we can examine, it's easy to see how entire eras of potential development could vanish without leaving behind anything we'd recognize. Sometimes when people imagine ancient civilizations, they picture societies that look like ours. Tall buildings, machines, transportation networks, tools made from metal and stone. But those expectations are shaped by the specific path humanity took. An earlier civilization might not have looked like us. It might not have built with stone or metal. It might not have carved monuments or used symbols that would survive erosion. Intelligence doesn't have to follow the same technological trajectory every time it appears. It could develop in ways we haven't considered. It might create things that leave no durable trace after millions of years. It might use materials that biodegrade quickly, or energy systems that produce no long-lasting residue. These possibilities don't prove anything, but they open the door inward. They help us think outside the narrow frame of human experience, and imagine intelligence not as a singular event, but as something that could arise whenever conditions allow for it. And those conditions, given enough time, could appear again and again. When geologists talk about deep time, they often describe it as something almost impossible for the human mind to fully grasp. We can picture 100 years, 1,000, even 10,000 if we stretch a bit. But millions of years? Hundreds of millions. Time like that behaves differently. It smooths out events, it erases details, it shifts continents as if they were paper notes sliding across a desk. Within such a vast space, entire worlds could come and go with only faint traces remaining. The whisper of forgotten beginnings doesn't insist on anything. It doesn't need certainty. It's more of a gentle suggestion that maybe the story of civilization is older, wider, and more layered than we've assumed. The Earth has been home to countless experiments in life. Intelligence could simply be another one of those experiments, repeating in cycles we haven't yet recognized. When you think about the sheer number of species that have existed and vanished, it becomes easier to imagine that intelligence might not be as unique as we think. There were creatures alive hundreds of millions of years ago that would seem almost alien to us now. Some had brains large enough to suggest complex behavior. Some lived in social groups. Some used strategies and communication that don't leave fossil evidence. Could intelligence have evolved in some ancient branch of life that left no trace recognizable to us? It's not impossible. It's simply unproven, and perhaps unprovable. There's something quietly grounding about exploring these possibilities without the pressure to draw a conclusion. Letting the imagination move slowly through the idea that humanity might be part of a much longer cycle can make our own existence feel both smaller and more connected. It doesn't diminish us, it puts us in context. Instead of being the beginning of the story, we might be one of many chapters, one expression of a pattern older than any of our structures or beliefs. Some scientists have even suggested ways to search for signs of ancient civilizations that might not leave behind traditional artifacts. Things like unusual chemical signatures in rocks, odd gaps in the fossil record, subtle disruptions in sediment layers, changes in the climate record that aren't easily explained by natural processes. These aren't the kind of discoveries that make headlines. They're the sort that require patience, precision, and a willingness to interpret clues without jumping ahead. But it's also possible that the whisper of forgotten beginnings isn't just about physical evidence. It could be about intuition, a sense that life on Earth has always been more complex than the lines we draw around it, that the planet has had time to host many stories, not just one. Sometimes people feel a strange recognition when standing among ancient landscapes or looking at weathered mountainsides. Not because they think something advanced built them, but because the age of the Earth itself carries a familiarity, as if deep time is something we recognise even if we've never lived through it. This sense of quiet recognition doesn't prove anything, but it does shape the way we think about beginnings. Instead of placing humanity at the start of the story, we place ourselves somewhere in the middle of a much larger one, and in doing so, we open the door to questions that allow us to imagine the world not as a linear progression, but as a series of rises and resets, each layer covering the one before it, each new age built on the silent foundations of the last. As we continue, the thought becomes not whether an ancient civilization definitely existed, but how life tends to experiment with intelligence whenever the conditions allow, how the planet resets itself after major events, how evolution adapts, tries again, shifts direction, tries again. And in that long rhythm, the idea of earlier civilizations doesn't feel like a stretch. It feels like a possibility waiting in the background, woven into the fabric of time in a way that's neither dramatic nor secretive. Just part of how a planet like ours might operate. And so the whisper continues, not demanding attention, not insisting on truth, but offering a gentle reminder that the beginnings we're familiar with may not be the first ones the Earth has known. There could have been others, quiet and distant, living and fading long before our ancestors learned to shape tools or gather around firelight. When you begin to picture the world before the world we know, it helps to set aside the landscapes we're familiar with. The forests, the seas, the cities, the migrations, the history lessons that stretch back only a breath into the planet's memory. Those things are recent, comfortingly recent. They give us the illusion that we stand on firm ground, that we know how the Earth has always looked, that mountains were always mountains and coastlines were always where they are now. But the truth is that almost nothing about our present world resembles the world that existed for most of Earth's history. The continents have wandered, oceans have opened and closed, entire ecosystems have appeared, thrived, vanished, and been replaced by others that did the same. If you peel back each layer of time, the familiar world slides away slowly, like old wallpaper revealing older layers underneath. Another pattern, another colour, another age with its own rhythm. And if you keep peeling, going far enough back beyond the era of mammals, beyond the age of the dinosaurs, beyond the great forest that once towered over swamps filled with dragonflies the size of birds, you eventually reach a place where the Earth looks almost alien. Not extraterrestrial, but foreign in a way that makes you realise how narrow our experience really is. Most people know that dinosaurs lived for over 150 million years, but what often gets forgotten is that Earth had already been a living planet for hundreds of millions of years before they appeared. Entire worlds rose and fell long before the first dinosaur ever left a footprint in soft mud. Those older worlds weren't empty. They were full of creatures adapted perfectly to environments we can barely imagine. Coral reefs flourished in places now covered by cornfields. Deserts lay where oceans are today. Ice caps extended deep into what we now call the tropics. And sometimes the opposite happened. The world warmed so much that almost no ice remained at all. Through all of this, the planet kept reshaping itself. Lakes drained, volcanoes resurfaced continents, rivers carved canyons and then filled them. The surface of the Earth is not a static stage. It's a constantly shifting puzzle, always being rearranged, always being rewritten. When you think about it that way, the idea of finding something ancient, intact and recognisable across tens or hundreds of millions of years becomes far less likely than we imagine. Anything delicate enough to be shaped by intelligent hands would face a long list of natural forces determined to break it down. The thought of earlier civilizations often gets tangled with the idea of human-like beings roaming ancient landscapes. But the world before the world we know didn't need to host anything like us to hold a civilization. Intelligence, if it ever appeared long before our own species, could have arisen in forms adapted to their own environments. Something ocean-dwelling, something forest-adapted, something that communicated in ways we wouldn't recognise now, something that may not have looked much like humans at all. Evolution doesn't promise consistency. It only promises change, adaptation, survival for as long as conditions allow. If you look at the fossil record, there are long gaps where entire eras of life are barely represented. Not because nothing lived then, but because fossilization is rare. Life thrives in soft tissues, shallow seas, swamps, forests, grasslands and riverbanks. But fossils need a very specific set of conditions. Most things that die don't fossilize. They decay, they're eaten, they're carried away by water, they vanish. If an ancient civilization existed before the world we know, it would face the same challenge. Most of its remains, like ours, would succumb to time long before they had any chance of turning into something durable enough to last. And then there's the matter of the continents themselves. Over hundreds of millions of years they drift. Oceans close and others appear. Entire land masses sink into subduction zones or rise from the seafloor. A city built in one age could be crushed beneath a mountain range in another. A structure carved into stone could be buried under layers of sediment thicker than any skyscraper. And once buried deeply enough, heat and pressure would change even the hardest materials beyond recognition. If something did exist before us, it would not be sitting neatly preserved like a forgotten museum. It would be blended into the geological record the same way ancient forests were transformed into coal, or the shells of sea creatures were pressed into limestone. Whatever remains there would be subtle, scattered and ambiguous. A chemical trace, an unusual mineral pattern, a layer of rock slightly out of place, nothing that would shout its origins, only hints, murmurs from a world erased by time. Imagine standing on a cliff overlooking the ocean. The waves below are steady, unhurried, carrying pieces of stone worn smooth by centuries of rhythm. The cliff itself is made of layers. If you trace those layers with your eyes, you're looking into the past in a literal way. Each stratum is a chapter in Earth's long story. But none of them are labelled. None of them tell you what was happening then in a way we easily understand. Geologists can read patterns. They can infer climate. They can recognise signs of life. But they're still interpreting fragments. The story is incomplete. There are entire pages missing. Some were never written down. Others were erased. Others were compressed into a different form altogether. That's the world before the world we know. A long series of ages that stretch back further than our imaginations can comfortably reach. Ages that make our entire history feel like an afterthought. Not in a discouraging way, but in a humbling one. Because stepping into that perspective makes you realise that Earth has had time, more time than we know what to do with, for countless possibilities to unfold. There's something steadying about that thought. It takes the pressure off the notion that humanity stands alone as the first and only advanced species. Maybe we are, maybe we're not. But the door isn't closed simply because we haven't found anything. Most of Earth's surface has been resurfaced, weathered, eroded, swallowed, or rebuilt by forces we have no control over. Even if we vanished tomorrow, the evidence of our existence would slowly blur until it became part of the landscape. Given enough time, even our most durable structures would cease to look like anything deliberate. They'd become stone, sand, dust. The more you look at deep time, the more you realise how much can be lost. If you go back 66 million years, you find the end of the dinosaurs. But if you go back just 10 million years earlier, the world already looks unrecognisable. And if you go back 50 million years before that, it's different again. The planet doesn't hold on to specific landscapes for long, not on the scale we're talking about. If an intelligent species lived 50 or 100 million years ago, the environment they shaped is gone, not metaphorically, literally gone. The land itself could be at the bottom of the ocean, or folded into the Himalayas, or melted into the mantle. It's natural to imagine that anything capable of building a civilization would leave behind vast residues, metal, plastics, tools. But that assumption relies on the idea that another civilization would develop like ours, that it would use the same materials, that it would extract minerals the same way, that it would build with similar methods. Intelligence doesn't guarantee similarity. The ancestors of octopuses evolved sophisticated brains on a path entirely separate from ours. Birds developed complex communication and problem-solving without resembling us in any way. Different evolutionary histories produce different solutions. If intelligence arose in a species long before humans, we can't assume it chose our materials. It might have chosen something biodegradable, something ephemeral, something that would not survive millions of years of erosion. If you walk through a forest today, you could pass an entire colony of ants with remarkable organisation and never see any trace of it from above. Scale matters, perspective matters, tool choices matter. Intelligence might appear in many forms, not all of which leave behind monuments. What's interesting about thinking this way is that it shifts the narrative from searching for lost cities to understanding how fragile civilization is, how easily erased, how dependent on stable climates, predictable seasons, and access to resources that change over time. If an earlier civilization arose during a warm period and then faced a sudden cooling event, it could collapse quickly. If it relied on a coastline that later disappeared underwater, its remains would be inaccessible now. The Earth has changed drastically many times. Entire eras have ended suddenly. Repeated extinctions reshaped life again and again. A civilization emerging in the wrong age could reach a peak, falter, and vanish between geological blinks. There's something almost peaceful in acknowledging that. It allows us to imagine timelines that don't revolve around us. It opens the possibility that Earth might have been home to experiments in intelligence before humans, and might host others long after we're gone. The planet moves on regardless. It doesn't cling to any one story. It supports whatever life adapts to each era and lets that life grow until conditions change again. Sometimes, when people think about ancient worlds, they imagine them as primitive simply because they're old. But the age of something doesn't determine its complexity. Early oceans held life that was sophisticated in ways we still struggle to understand. Some creatures had compound eyes long before mammals appeared. Some developed societal behaviour. Some coordinated in ways that don't leave behind fossils. Intelligence might not leave a footprint unless it interacts with its environment in a durable way. And even then, durability doesn't guarantee longevity. The world before the world we know wasn't a single era. It was countless eras. Some warm, some frozen, some bursting with life, some sparse and quiet. Each one had the potential to create something unexpected. Each one had the potential to erase what came before. And each one unfolded at a pace that makes our own chapter feel incredibly small. But small doesn't mean insignificant. It just means we're part of a timeline much wider than our own stories admit. That's what makes this exploration so calming. It allows us to loosen our grip on the belief that history begins with us, that intelligence starts with us, that civilization is unique to us. Instead, we start to see ourselves as one expression of a broader potential, one result of conditions that, given enough time, might lead to intelligence again and again. The surface we walk on feels permanent because it doesn't change much within a single lifetime, but over long stretches of time it behaves almost like water. It moves, folds, sinks, rises, and rearranges itself in ways that hide whatever once stood on it. That makes the idea of discovering anything truly ancient a much quieter pursuit than people expect. Instead of stumbling upon towering ruins or intact remnants, you find yourself searching for small irregularities, a disturbance in a layer of sediment, a mineral concentration that's slightly unusual, a faint signature of something that doesn't quite match the patterns we know. Most of the time, these inconsistencies have ordinary explanations: a change in climate, a volcanic event, a shift in an ancient river's path. But occasionally there are things that make researchers pause, not because they point loudly to a forgotten civilization, but because they raise questions that don't have clear answers yet. These are the places where imagination and scientific curiosity meet in the middle, neither overpowering the other. They whisper rather than declare. And listening to those whispers can be strangely calming, as if you're gently dusting off corners of Earth's memory that haven't been touched in a very long time. If you think about what survives in soil and stone, it's usually things nature has embedded, not things created intentionally. Fossils, fragments of shells, plant impressions, and chemical traces of ecosystems that lived and died long before humans evolved. These layers of sediment form a record, but it's incomplete. Entire eras are missing. Some were washed away before they could be preserved. Others were crushed beneath glaciers or swallowed by tectonic plates. When scientists try to piece together the full story of the Earth's past, they're working with pages torn from dozens of books, each one presenting only a small part of the whole. That fragmentation is important when thinking about whether traces of an earlier intelligent species could survive. If entire oceans of life left nothing behind except a thin layer of clay or a scattering of microfossils, then the absence of clear evidence for a civilization isn't surprising. What you'd expect to find, if anything survived at all, would be indirect signs, patterns that don't fit easily into what we know about natural processes. The hints wouldn't look like objects, they would look like irregularities. There are debates in geology about certain layers of rock that seem unusually rich in specific elements or compounds. Some of these layers have natural explanations tied to ancient eruptions or asteroid impacts. Others remain uncertain. For example, there are strata containing unusual concentrations of metals that don't typically appear in that combination. There are layers where magnetization patterns shift rapidly, as if the environment changed faster than expected. None of these things prove anything about ancient civilizations, but they serve as quiet reminders that the Earth holds mysteries we haven't fully deciphered. Sometimes the questions come from the fossil record itself, not from absence, but from abrupt transitions. There are periods where species appear or disappear with surprising speed, suggesting environmental changes that don't always match the geological evidence we've gathered. A rapid shift in climate might explain it. So might volcanic activity. So might events we haven't identified yet. When viewed through the lens of deep time, abruptness is relative, but even relative abruptness can be curious. It's as if the planet underwent a reset, clearing the way for something new. That kind of reset doesn't require intelligent cause, but acknowledging resets as part of Earth's natural rhythm makes the idea of earlier cycles feel more plausible. Another subtle clue sometimes discussed among scientists is the presence of odd microstructures found in stone. Most of these structures turn out to be natural formations, crystals, weathering patterns, pressure seams. but occasionally something shows up that looks almost intentional at first glance. A pattern of grooves, a set of intersecting lines, a shape that resembles a tool mark. In nearly every case, longer analysis reveals a geological cause: water flow, freeze-thaw cycles, mineral expansion. But the fact that these natural processes can produce shapes that mimic artificial ones is interesting. It reminds us how easily traces of civilization could blend into the natural record until they become indistinguishable from it. The soil also holds stories that are easy to overlook. When archaeologists study human civilizations, they often rely on soil composition to identify ancient habitation, a slightly different ratio of elements, a patch of earth that's richer in organic matter. But these signals only last if the soil hasn't been disturbed too deeply. Across millions of years, almost every patch of ground on Earth gets overturned, buried, or washed away. Even the most dramatic chemical signatures fade into the background. If something lived long before humans and left behind subtle shifts in soil chemistry, those shifts would likely be smoothed out by time until they were part of the ordinary landscape. There are also a few geological oddities that invite questions because they resemble something manufactured. Ancient spherical stones found in various parts of the world, for example. Some are clearly natural, others are less easily explained. Perfectly round spheres can form through natural processes, but the precision of some examples has led people to wonder whether they were shaped intentionally. Scientists continue to study them, and most are eventually attributed to geological processes, but the fact that these objects exist at all reinforces how easily nature can create forms that trigger our pattern recognition. Another curiosity comes from ancient mining sites that don't match the timeline of human development. Certain areas contain evidence of mineral extraction far older than expected. There is debate about whether these marks were made by natural processes, or whether early humans, long before organised societies, experimented with resource gathering in ways we haven't yet understood. Nothing about these sites conclusively points to an earlier civilization, but they add to the long list of questions that linger quietly in the background. If you imagine trying to detect our own civilization millions of years in the future, the challenges become clear. Our plastics would break down, our metals would corrode, our buildings would crumble. Most of our artifacts would be unrecognisable. What might remain would be a thin layer of unusual chemical composition, an elevated level of carbon from industrial emissions, residues from plastics, traces of synthetic materials. But even these signals would fade over time. The Earth is very good at burying and blending. The deeper you go into geological layers, the more difficult it becomes to distinguish natural from artificial. That's why some researchers suggest that if an ancient civilization existed, the most likely traces wouldn't be objects at all. They'd be chemical anomalies, slight increases in certain gases trapped in rock formations, unexpected concentrations of elements that could signal industrial processes. But interpreting those anomalies would be challenging. Nature produces its own chemical oddities through volcanoes, asteroid impacts, ocean chemistry shifts, and biological processes. Distinguishing an artificial signature from a natural one requires a level of context that might be impossible to obtain millions of years after the fact. Still, people continue to find small irregularities in the geological record that raise quiet questions. For example, there are layers containing metallic spheres so tiny and uniform that they look engineered under a microscope. Most geologists attribute them to ancient volcanic eruptions or meteor impacts, but their precision leads some to wonder about alternative explanations. Again, not as evidence, but as an invitation to think differently about what might remain from a world erased by time. Another peculiar trace comes from extremely ancient rock formations that have unusually straight lines and geometric patterns within them. Natural crystal structures can create surprising shapes, including perfect squares and hexagons. Patterns in sedimentary rock can also mimic designs that look intentional. But in some regions, the geometry is striking enough to make people pause. The most likely explanation is geological. Yet the resemblance to deliberate foundations or walls, even if coincidental, reminds us how the mind gravitates toward meaning. Sometimes traces come in the form of absences, layers where something should be present but isn't. Periods where fossil activity drops sharply without a clear environmental cause. Sediment deposits that are thinner or thicker than models predict. These gaps can be attributed to erosion, changes in sea level, or shifts in climate. But they also highlight how incomplete the record is. Whole worlds could rise and fall in these missing stretches, leaving behind little more than a disruption in the normal rhythm of sediment. It's this incompleteness that makes the search for ancient precursors so intriguing. You're not hunting for monuments, you're looking for faint disturbances, the same way you might notice a slight unevenness in the ground and realise it once held something more. This approach isn't about proving a theory, it's about recognising that Earth's record is patchy, that it's filled with shadows of things we can't fully see, and that those shadows might, just might, include traces of something unexpected. There's also the matter of ancient artifacts that appear out of place. Most of these so-called anomalies have been debunked or reclassified as natural formations or misinterpretations. But a small number remain curious. Objects that don't fit easily into the timeline we're familiar with. Iron fragments in layers older than the species we associate with metalworking. Spherical objects encased in stone far older than human civilization. Again, these are likely natural phenomena or errors in reporting. But their existence keeps the door open just wide enough to let imagination wander. It's important to stay grounded when thinking about these things. The mind is quick to jump from mystery to conclusion, but the true value in these traces is not in what they prove, but in what they allow us to consider. They remind us that the story of Earth is larger than we can easily comprehend, that human history sits on top of an ancient foundation filled with unanswered questions, and that even though we may never find definitive evidence of a predecessor civilization, the possibility itself expands the way we think about our place in the world. The soil keeps its secrets in quiet layers. The stone holds shadows that hint at stories we haven't pieced together, and somewhere in those layers and shadows lies the sense that we're not reading a full timeline, but only the visible fragments of a much longer one. When you think about civilizations rising, it's easy to picture grand moments. The first spark of agriculture, the first shared language, the first city with its early forms of trade and structure and organisation. But the path from scattered groups of individuals to something we later call a civilization isn't a straight line. It's slow, uneven, and filled with long pauses where nothing seems to change at all. Civilizations don't appear out of nowhere. They emerge one slow adjustment at a time, shaped by the land, the climate, the available resources, and the needs of the people living through those conditions. And just as importantly, they can disappear in ways that feel almost gentle when viewed across large stretches of time. When archaeologists study the rise of any known civilization, whether it's ancient Mesopotamia, the Indus Valley communities, the Maya, or early Chinese dynasties, they often find that their beginnings are quiet. You don't see an explosion of structures all at once. Instead, you see a subtle shift in how people lived. A village becomes a larger one, a few homes become a cluster becomes a settlement. Then storage facilities show up, then specialised tools, then larger gathering spaces, and eventually those spaces grow into something recognisable as a city. If you zoom out far enough, you can see the pattern. Civilizations rise because conditions allow them to. They appear when food is abundant enough to support large groups, when stability allows people to think beyond day-to-day survival, when their surroundings encourage cooperation, trade, and shared knowledge. And this rise doesn't happen because one person invents something dramatic. It happens because small changes accumulate until the world shifts without anyone realizing how significant those changes will become. What's interesting is how similar the decline of civilizations looks when examined from a distant perspective. From close up, it feels dramatic. conflicts, droughts, migrations, economic collapses, changes in leadership. But if you look at those events from the long view of geological time, the decline becomes just as subtle as the rise. Fields dry, trade routes shift, populations thin out, cities shrink. A structure collapses and is never repaired. Someone moves to a place with better soil or calmer weather. A generation forgets what the last one built. Another generation forgets why it was built. And slowly, almost invisibly, the civilization fades into the landscape. That's how every known civilization on Earth, no matter how powerful it once was, eventually dissolved. Some were wiped out quickly by disasters, but most simply faded because conditions changed. They didn't fall with a single event. They folded away over time, leaving behind ruins that would later be weathered, buried and forgotten until hours of patient excavation brought them back into view. Now imagine stretching that entire process, the slow rise and the quiet decline, not over a few thousand years, but over millions. Conditions that allow for intelligence and complexity don't appear often, but when they do, the rise could follow familiar patterns. A species learns to coordinate. It develops tools, though maybe not ones we'd recognise. It forms social structures. It discovers ways to harvest energy or shape its surroundings, and gradually, without realising it, it becomes advanced. This kind of rise wouldn't be sudden or noisy. It would be a long unfolding, shaped by natural forces and biological evolution. And if the conditions that supported it shifted, the decline would be just as quiet. No dramatic collapse, no single event marking the end. Just a gradual thinning out until nothing remained of what once defined that civilization. What makes this thought compelling is how consistent it is with what we know about Earth. The planet has always moved in cycles. Ice ages come and go. Sea levels rise and fall. Asteroids impact. Volcanoes erupt. Climates shift. Ecosystems reorganize. These fluctuations create windows where life can flourish in new ways, and windows where that flourishing becomes difficult. Some species adapt, some don't. Some succeed for a while, and then conditions push them back toward extinction. If a civilization existed long before ours, its rise would be tied to the conditions that allowed it to happen. Its decline would follow when those conditions changed. It wouldn't need to leave behind obvious ruins. It wouldn't need to leave behind objects that could survive deep time. It would need only enough time to grow, make sense of its world, improve its survival, and eventually face challenges that made continuation difficult. Even in our own recent history, civilizations that thrived for centuries disappeared so thoroughly that discovering them required piecing together what remained under soil, ash, or water. Some structures disappeared completely because the materials used were organic: wood, fibre, thatch, clay. Even stone doesn't last forever. Sandstone softens, limestone dissolves. Volcanic activity can erase landscapes wholesale. Flooding can bury everything under layers of sediment. Time presses down on whatever's left until it becomes part of the earth around it. When people imagine the disappearance of a civilization, they often picture abrupt destruction. But more often, what causes a civilization to fold away is slow. A shift in rainfall patterns, a change in available resources, a disease that spreads quietly over generations, the exhaustion of a key food source, a migration that begins as necessity and becomes permanent. And once enough people leave an area, the structures they once maintained begin to fade. Even today, there are towns abandoned only a few decades ago that already show the early signs of disappearance. Roads cracking, buildings leaning, vegetation pushing through floors and walls. If left alone for a century, those structures would be difficult to recognize. For 1,000 years, even more so. Given 1,000,000 years, everything would blend back into the environment unless preserved under some unusual condition. And if the land itself shifted, the traces would be scattered beyond recognition. There's also the influence of population scale. A civilization doesn't need to be global to be advanced. It doesn't need billions of individuals. Even a relatively small group with enough knowledge and coordination could become sophisticated in ways that don't necessarily leave behind extensive remains. A small, intelligent species living in isolated regions might develop complex social structures without building anything that would survive deep geological time. They might have technologies that don't fit our expectations. They might rely on biological materials. They might inhabit environments that don't fossilize easily. If such a civilization rose and declined before humans existed, its disappearance might leave behind no more than subtle geological disturbances, a pocket of unusual chemical deposits, a disruption in a sediment pattern, a layer of soil slightly richer in a particular mineral, and those clues, buried under millions of years of Earth's shifting surface, would be almost indistinguishable from natural variation. Some scientists point out that the rise of an intelligent civilization could take a direction so unlike our own that its traces would be invisible to us. Intelligence doesn't require industry. It doesn't require metal. It doesn't require cities. It only requires adaptation and the ability to solve problems. If a species evolved in an environment where building permanent structures didn't provide any advantage, it might never leave behind artifacts. If it used sound, chemical signals, or electromagnetic communication rather than written language, nothing would survive in the fossil record. If it developed technologies based on organic materials, nature would reclaim them almost immediately once the species disappeared. When considering these possibilities, you start to understand how easily entire civilizations could rise and fall without leaving a visible trace. The Earth's surface is not a museum. It's an active, shifting environment. Within just a few 100,000 years, a blink in geological terms, an entire landscape can change beyond recognition. Within 1,000,000 years, whatever once existed might be completely erased. Within 10 million, it might be recycled into rock, melted, or pushed deep below the crust. Yet the pattern of rise and decline is deeply familiar to us because we've seen it play out repeatedly within the relatively short timeline of recorded history. Civilizations rise in fertile regions, they expand, they build, they share knowledge and develop unique cultures. They create systems of trade, governance, and belief, but those systems depend on stability. When the environment changes, the systems falter. When resources shift, lifestyles shift with them. When populations move, old structures lose their purpose. And gradually the civilization that once flourished becomes a memory held in the landscapes that shaped it. It's helpful to see these patterns not as failures, but as part of the natural rhythm of life on Earth. Civilizations rise because conditions allow them to. They fold away because conditions change. Nothing rigid survives indefinitely. Flexibility helps, but even the most adaptable societies eventually face situations where their structures no longer fit their environment. Sometimes the decline is accelerated by conflict or disaster. Other times it's simply a slow unravelling. That gentle unravelling is important when imagining civilizations that might have existed before us. If any such civilization appeared millions of years ago, the timeline of its rise and fall would be so long that even the memory of its existence would be washed away by shifting continents, evolving species, and cycles of climate change. It wouldn't look like a sudden collapse. It would look like the gradual disappearance that all civilizations eventually experience, stretched across a scale that makes the disappearance absolute. In a way, this idea gives our own existence a kind of softness. It reminds us that nothing humanity builds, no matter how advanced, will last forever. Even our longest-lasting structures will eventually erode, corrode, or be overtaken by environmental changes. The Earth keeps moving. It doesn't hold its shape for us, or for anyone else. And that movement makes the rise of civilizations feel like something temporary, but not fragile. More like a natural process tied to the conditions of a particular moment. Thinking this way brings a sense of balance to the idea of an ancient precursor civilization. It doesn't require imagining beings far more advanced than we are. It only requires acknowledging that intelligence could have arisen when conditions were favourable and faded when they were not. The rise and fall would be part of Earth's long pattern, just as our own civilization is now part of that same pattern. This understanding creates a quiet continuity between us and whatever might have come before. It allows us to see humanity not as the first, but as the current expression of what the planet can produce under the right conditions. Intelligence becomes part of a repeating cycle, rather than a single unprecedented event. And civilizations, no matter how impressive they become, remain temporary inhabitants of a world that will continue evolving long after they fade. When you begin thinking about whether traces of an earlier civilization might exist somewhere in the vast span of Earth's history, it's natural to look at the discoveries that don't quite fit into the standard timeline. Not because they prove anything dramatic, but because they create small pauses in the story we've built for ourselves. A bone that's older than expected, a tool-like shape in a layer of rock that shouldn't contain anything made by hands, a geological pattern that looks out of place. These things usually have reasonable explanations, but the questions they raise tend to linger in the background of scientific conversation like faint echoes. The idea of puzzle pieces found too late isn't about claiming that anything specific belongs to a forgotten civilization. It's about acknowledging that the record we have is incomplete, full of gaps and uncertainties. Earth doesn't archive its past neatly. It stores memories unevenly, preserving tiny details from some ages while erasing entire sections from others. When researchers uncover something strange, they're often faced with the challenge of deciding whether what they found is an exception to what they already understand or a clue pointing to something they haven't imagined yet. Some of the earliest puzzle pieces came from fossils that didn't fit the expected pattern. A footprint here or there, discovered in rock layers far older than anything that should have legs to make them. Most of these are eventually attributed to erosion or natural formations. Rock can split in ways that mimic footprints. Sediment can shift and leave impressions that resemble intentional shapes. But before the explanations arrive, there's a moment of quiet possibility. A moment where someone wonders whether this could be a leftover from a story older than the one we know. There are tools too, or things that look like tools. Sharp stones shaped in ways that appear deliberate. Objects with edges that seem too precise for pure chance. Archaeologists debate these finds often. Some argue that early humans or human-like ancestors may have crafted tools much earlier than previously thought. Others point to geological processes that can fracture stone into tool-like shapes. The discussion itself shows how easily the past can blur. A single flake of rock can spark a debate that lasts years, and yet it might be nothing more than the result of a stone cracking under pressure. Then there are the artifacts found in places that don't match their age. Pieces of metal embedded in rock layers millions of years old. Spheres of strange composition discovered deep underground. These items often turn out to be intrusions, objects that slipped into older layers through cracks, water flow, or geological disturbances. But occasionally their presence remains unexplained. Not in a sensational way, but in a quiet, unresolved way that reminds researchers that Earth is old enough for countless anomalies to exist without needing extraordinary explanations. One of the most debated pieces comes from the idea that certain ancient structures around the world might be older than conventional dating suggests. Not because they contain signs of advanced ancient societies, but because some appear built upon layers of even older and more worn foundations. In these cases, it's difficult to tell whether the foundation was shaped intentionally, or whether natural formations were simply used as convenient supports. Weathered stone can mimic craftsmanship. Repeated freezing and thawing can create patterns that seem too orderly to be natural. When an ancient human civilization built something on top of those forms, the line between nature and design can blur so completely that interpreting it becomes a puzzle that may never be solved with certainty. Scientific tools have become more sophisticated over time, allowing researchers to analyze soil composition, mineral content and microstructures in stone with remarkable precision. But even with these tools, interpretations differ. One researcher might argue a pattern was formed by natural processes. Another might believe it shows intentional shaping. These disagreements don't undermine science. They highlight the complexity of reading Earth's past, especially when the evidence is faint or fragmented. Some puzzle pieces come not from objects but from the planet's climate history. Certain transitions between ages appear unusually fast. Temperatures shift abruptly. Sea levels rise or fall in ways that don't match known causes. Most of the time, these changes can be attributed to volcanic eruptions, orbital shifts, or asteroid impacts. But occasionally the timing feels off. The scale feels inconsistent. It creates a small gap in our understanding. A blank space that could be filled by a variable we haven't discovered yet. If a past civilization existed, even a small one, it could have influenced its environment in ways that left traces resembling natural climate events. A species capable of altering landscapes or using energy might unintentionally leave behind chemical changes, but interpreting those changes millions of years later would be nearly impossible. A spike in a particular compound might suggest industry, or it might suggest a volcanic event we haven't yet identified. The ambiguity leaves room for the imagination, but not for certainty. Another type of puzzle piece appears in the fossil record: gaps where certain species vanish quickly while others appear suddenly. Most of these transitions are understood through theories of natural selection, environmental shifts, or mass extinctions. But there are periods where the changes seem unusually sharp, as if something interrupted the normal flow of evolution. Some researchers suggest these gaps may reflect incomplete fossil records. Others wonder whether they hint at unknown events that shaped life in ways we don't yet understand. Of course, natural explanations tend to be the most likely. The Earth has experienced countless upheavals, asteroid impacts, massive volcanic eruptions, and shifts in atmospheric chemistry can all reshape ecosystems dramatically. But the unanswered questions still whisper faintly. They suggest that while we've learned much about geological history, there is much more we haven't yet discovered. Occasionally, researchers come across objects known as out-of-place artifacts. These are items that appear too technologically advanced or too well crafted for the period they're found in. Many of these turn out to be misidentifications, modern objects that infiltrated older layers, hoaxes created to attract attention, or natural formations mistaken for artifacts. But a few remained unclassified. A tiny metal sphere embedded in ancient mineral deposits, a piece of iron whose age doesn't align with human activity, a fragment of something shaped, then buried, then forgotten. These items rarely prove anything definitive, but they serve as small reminders that not everything fits neatly into our timeline. They may have ordinary explanations we haven't uncovered yet, or they may hint at events that lie outside our current understanding. Neither possibility disrupts the broader picture of Earth's history. They simply add depth to it. They invite curiosity without demanding conclusions. Sometimes the most intriguing puzzle pieces come from places beneath the ocean. Much of Earth's surface was once land, later submerged as sea levels rose. Underwater landscapes hold secrets from eras long before recorded history. Structures resembling terraces, patterns that look like roads or walls, and formations that seem deliberately aligned have been found in various locations. Most are explained by natural processes, fault lines, erosion, coral growth, or volcanic activity. But ocean floors are some of the least explored regions on Earth. There may be traces we haven't identified yet simply because they're hidden under layers of sediment, or because no one has looked closely enough. If a civilization existed long before humans, it could have developed near coastlines, just as ours has. Over millions of years, coastlines shift dramatically. What is now ocean floor might once have been fertile land. Any structures built in those regions would now be buried under thick layers of sand, mud, and marine life. Underwater erosion smooths edges quickly. Coral overtakes surfaces. The ocean is efficient at blending the artificial into the natural. Another area that holds unexplained elements is ancient mining. There are sites where mineral extraction appears older than human presence in that region, Some scientists attribute these to early humans or human-like ancestors, experimenting with tool use earlier than we believed. Others suggest natural processes carved out shapes that mimic mining. The difficulty lies in interpreting limited evidence. A hollow in a rock could be the beginning of a mine or the result of weathering. A collection of stones could be debris from human activity or the product of geological layering. Without clear context, the line between these interpretations becomes thin. The puzzle pieces grow even more subtle when you look at chemical signatures in ancient rocks. Certain layers contain compounds that are difficult to explain through known natural processes. Unusual concentrations of particular isotopes, residues that might represent synthetic chemicals, patterns in sediment that hint at large-scale changes in land use. Most of these observations remain unresolved because we lack the data needed to interpret them. They're fragments of a story without enough pages to understand the plot. Even the presence of microplastics in geological layers today shows how future researchers might misinterpret our own civilization. If someone studies Earth's crust millions of years from now, the plastics we leave behind will long have broken down. What remains may be faint chemical traces easily confused with natural phenomena. Our skyscrapers will be gone, our metals dissolved, our cities buried or melted. If advanced beings appear millions of years after us, they will face the same uncertainties we face when looking backward. This is why the puzzle pieces we find today matter. They aren't evidence of anything specific. They're reminders of how difficult it is to read the ancient past with confidence. A slight variation in soil composition could suggest a settlement or could reflect a long-lost forest. A strange pattern in rock might represent a natural fracture or an artifact from an unknown source. The ambiguity isn't frustrating, it's humbling. It reminds us that we're piecing together an enormous puzzle with many missing sections. Some of the most interesting puzzle pieces aren't objects at all, but patterns across different fields of study. Climate changes, extinction events, odd gaps in evolution, unexplained mineral layers. All these threads weave together in ways that invite curiosity. Each thread alone might be ordinary, but together they create space for the question of whether something existed before us, something intelligent in a form we might not immediately recognize. The important thing is that the idea doesn't hinge on any single piece. It doesn't depend on proving a specific artifact was manufactured or that a geological anomaly must have an artificial explanation. Instead, the idea lives in the spaces between what we know and what we don't. The puzzle pieces we found too late are simply markers of those spaces. They show us that there are questions still to ask, regions still to explore, interpretations still open. The Earth keeps its stories in layers. Some layers are clear, some are blurred, some are missing entirely. Whatever mysteries lie there aren't necessarily trying to be discovered. They're simply part of the planet's long, complex memory. And we, arriving so late in the timeline, are doing our best to understand fragments of a narrative that was already ancient before our first tools were shaped. When people talk about mysteries from the past, they often focus on objects or structures. Stones arranged in ways that don't immediately make sense. Artifacts that seem too well crafted for the time period they're assigned to. Cities whose construction techniques appear more advanced than expected. But sometimes the most puzzling clues aren't physical at all. They come in the form of knowledge, ideas recorded in ancient texts, patterns in myths, observations made by early cultures that seem, on the surface, far too accurate for the tools they supposedly had. These moments create a particular kind of quiet tension, the kind that makes you pause and wonder how such information ended up in the historical record. Knowledge is one of the easiest things for a civilization to lose. Even in our own time, information can fade quickly if it isn't written down or preserved. Traditions change, languages shift, libraries burn, oral stories transform as they pass from one generation to the next. And yet, despite that fragility, some pieces of ancient knowledge survive with surprising clarity, not because they were protected intentionally, but because they were embedded in cultural memory so deeply that they resurfaced even after the civilizations that created them disappeared. One example often mentioned is ancient understanding of astronomy. Long before modern telescopes existed, early cultures mapped the sky with impressive accuracy. They tracked star movements, measured solstices, predicted eclipses, and aligned structures with cosmic events. People sometimes assume these achievements imply something extraordinary, but careful observation over long periods can explain much of it. A culture that depends on the stars for navigation or agriculture will naturally become skilled at reading the sky. Still, certain details remain striking. Some of the alignments are so precise that it's difficult to imagine how they could have been achieved without instrumentation. But rather than jumping to conclusions, it's helpful to remember that human patience can produce remarkable results, especially over generations. What becomes more intriguing is when ancient knowledge seems to extend beyond direct observation. For instance, there are myths and stories from multiple regions describing periods of global flood, dramatic climate change, or cataclysmic events that align broadly with what we now know about geological history. These stories may have originated from real events like rising sea levels at the end of the last glacial period, but there are times when the details feel almost too specific. Descriptions of lands disappearing beneath rising water, accounts of long-lost coastlines, memories of earlier peoples with abilities different from the storyteller's own. We usually interpret these as symbolic or exaggerated accounts of natural disasters. That interpretation is sensible, yet the consistency of certain themes across cultures raises questions about what memories might have survived long after their origins were forgotten. In some cases, ancient people described geological events with surprising accuracy. They told of mountains forming in single days or islands rising from the sea. These are often considered mythology, but volcanic eruptions can create land rapidly. Earthquakes can reshape landscapes overnight. Oral traditions sometimes preserve details of events that occurred thousands of years earlier. That doesn't imply advanced knowledge. It simply shows that human memory, passed down through stories, can be more durable than we assume. But occasionally the puzzle becomes harder to dismiss. Certain structures and artifacts reflect knowledge that seems ahead of their time. For example, there are ancient documents showing that early cultures understood the approximate size of the Earth long before European scientists formally calculated it. They created surprisingly accurate calendars. They tracked planetary cycles with precision that matches modern values. Some even describe phenomena such as precession, the slow wobble of Earth's rotational axis, something that requires long-term observation to detect. None of these achievements require advanced technology, but they do require generations of meticulous observation, mathematical reasoning, and cultural stability. What makes them intriguing is that they appear almost suddenly in the archaeological record. A culture goes from basic subsistence living to sophisticated astronomical understanding in what looks like a short span of time. That suddenness may simply reflect gaps in the record, but it also leaves room for curiosity. How much knowledge existed before the earliest surviving evidence? How much might have been inherited from prior groups whose own tools and structures didn't survive long enough to be discovered? There are also anomalies in early engineering. Massive stones moved with methods that aren't fully understood. Walls built with joints so tight that blades can't slip between them. Foundations more advanced than the structures above them. In many cases, researchers conclude that the builders had techniques that haven't been preserved in writing. Ancient people were inventive and skilled, often solving engineering challenges through trial and error, experimentation, and an understanding of materials passed down through generations. But there are still elements that raise quiet questions. Some construction methods appear unexpectedly efficient. Some alignments seem too precise to be accidental. Some knowledge surfaces without clear developmental steps in the archaeological record. These situations don't demand fantastic explanations. They simply remind us that history isn't a complete story. It's a collection of surviving fragments, and much of what happened between those fragments is unknown. There are even hints in ancient medicine that seem advanced. Early cultures performed surgeries, set broken bones, and used herbal remedies that modern science has validated. They created early forms of anesthesia. They understood the importance of certain minerals, plants, and compounds long before chemistry existed as a field. Many of these practices likely came from trial, experience, and generational knowledge, but the precision of some early techniques suggests a depth of understanding that wasn't always reflected in the tools they left behind. When people encounter these examples, they sometimes imagine that ancient civilizations must have inherited knowledge from a much older source. That idea doesn't need to be literal. A more grounded explanation is that human societies have repeatedly risen to surprising levels of sophistication, only to lose much of that knowledge when environmental or social changes disrupted their development. In that sense, the knowledge that seems out of place might be the remnants of an intellectual peak that was later followed by decline. If we assume that intelligence might have arisen on Earth more than once, then it becomes reasonable to imagine that some knowledge could have been preserved indirectly. Not through writing or artifacts, but through patterns of behaviour that echoed down the ages. A species that lived long before humans might have discovered mathematical relationships, or observed astronomical patterns that were later rediscovered, not because they were handed down directly, but because the same world produces the same problems and the same solutions. In that view, the knowledge isn't mysterious. It's simply a sign that intelligence, whenever and wherever it develops, tends to notice similar things about the environment. Still, there are pieces of knowledge that feel unusually advanced. Some myths seem to reference geological timescales. Others describe multiple cycles of creation and destruction, or ages of the world separated by long-forgotten events. These stories might be metaphorical, but they might also represent memories of earlier periods of global change. It's difficult to know which interpretation is correct. Oral traditions don't carry timestamps. They can merge local events with older ones. They can preserve fragments of truth that become woven into symbolic narratives. There are also mathematical systems that appear almost fully formed when they first show up in history. Complex calendars, systems for predicting celestial events, counting methods that extend far beyond immediate practical needs. In some cases, the mathematics used by ancient cultures seems unusually abstract for societies that had only recently developed agriculture or written language. Again, this doesn't require an extraordinary explanation. Human curiosity is capable of great leaps, but it does raise the possibility that earlier groups, now lost to time, might have experimented with similar ideas, leaving behind no trace except patterns later rediscovered. Some early cultures understood aspects of geometry with surprising precision. They grasped the relationships between angles and lengths. They built structures with accurate proportions. They created tools capable of producing consistent measurements. These achievements likely evolved through observation and hands-on experience. Yet the speed with which some communities adopted these methods remains puzzling. Knowledge usually develops gradually, but in a few cases it appears to have advanced rapidly, as if built on previous foundations that have since disappeared. There are also hints in mythology that suggest earlier sophistication. Stories that describe cycles of destruction and renewal could reflect memories of actual events. Volcanic eruptions, meteor impacts, dramatic sea level changes, or long-term climate shifts. These events might have affected early humans deeply enough that their memory was preserved in symbolic form, but some of the details feel more like observation than metaphor. Descriptions of distant landforms, knowledge of currents, insights into the shape of the world, all without tools that should have made such understanding possible. Of course, myths evolve. They absorb influences from multiple sources. Over time, symbols and facts blend together. But the persistence of certain themes across cultures separated by oceans and continents suggests that some ideas were shared much earlier than recorded history indicates. Those common elements might be coincidence. They might reflect universal human experiences, or they might indicate that earlier groups travelled, communicated, or explored in ways that haven't been documented. Then, there are the physical puzzles that hint at advanced craftsmanship. Metal objects forged with techniques believed to be discovered much later. Alloys that shouldn't exist for their time. Items coated with protective layers that remain durable even today. These examples are rare and often debated, but they have a way of reappearing in academic discussions when researchers attempt to understand how certain technologies developed. Some of these items might be modern intrusions, others might be misidentified, but a few are genuinely puzzling. They raise the question of whether earlier cultures experimented with metallurgy or chemistry in ways that left only traces of their achievements. Tools made from organic materials wouldn't survive. Techniques requiring specialized knowledge might have vanished when the societies that used them declined. The absence of documentation doesn't mean the knowledge never existed. It simply means it was lost. This loss creates a pattern repeated across history. Civilizations rise, develop complex knowledge systems, then face disruptions that scatter their people and erase their achievements. When the environment shifts or a population relocates, knowledge can disappear in a single generation. Written records can be destroyed by fire, water, or conflict. Oral traditions can shift as storytellers adapt them. Skills can fade when no longer needed. Over thousands of years, those losses accumulate until even sophisticated understanding becomes unrecognizable. If that can happen within the span of human history, imagine what could vanish across millions of years. Imagine how many cycles of knowledge might have developed, peaked, and dissolved long before anything we associate with civilization existed. Some of that knowledge might have been rediscovered by humans later. Mathematics, navigation, astronomy, medicine, engineering. These fields often depend on universal principles. Any intelligent species observing the world would encounter similar problems and invent similar solutions. The knowledge that seems too advanced for ancient humans might not be the remnants of a single forgotten society, but echoes of recurring patterns that intelligence naturally uncovers. This possibility doesn't diminish the accomplishments of past civilizations. It expands our understanding of how knowledge emerges. It suggests that human innovation might not be a solitary event in Earth's history. It could be part of a cycle in which intelligence continually rediscovers truths about the universe. Even within human development, certain insights arrive suddenly without clear precursors. People learned to track the stars. They mapped the Earth. They measured distances with accuracy. They predicted seasons with mathematical precision. These breakthroughs appeared in different parts of the world independently, often without contact. That independence might indicate that knowledge isn't random. It might be a natural outcome of cognitive evolution. Whenever intelligence reaches a certain level, it begins to notice patterns that lead to similar conclusions. When thinking about ancient knowledge that shouldn't be possible, it's important to maintain balance. Nothing demands an extraordinary explanation, but the existence of these puzzles makes the conversation richer. They open the door to ideas that might otherwise seem unnecessary. They remind us that we don't fully understand the pathways by which knowledge moves, whether through direct inheritance, rediscovery, or cycles much older than we currently imagine. When people hear the phrase, the Great Reset, it often brings to mind images that are sharper than the topic really deserves. Large dramatic events, sudden endings, cataclysms that wipe the slate clean in a single moment. But when you look at how the Earth actually works, resets are usually quieter than that. They happen over long stretches of time, shaped not by one event, but by a combination of changing conditions. And those changes don't always obliterate what came before. Sometimes they simply alter things slowly enough that the original world dissolves without anyone noticing until it's already gone. In conversations about whether civilizations might have existed long before ours, the idea of resets becomes unavoidable. Not because we're searching for apocalyptic stories, but because the planet has undergone so many transformations that it would be strange to think intelligence has only ever risen once. Reset theories explore these transformations with a kind of cautious curiosity. They don't insist that an advanced species existed before humans. They simply acknowledge that the Earth provides windows where intelligence could thrive, and windows where it would face challenges too great to survive. These ideas have soft edges for a reason. They aren't built on definitive evidence. They're built on possibilities, observations, geological patterns, and the knowledge that time can erase almost anything. Approaching the topic with gentle curiosity rather than certainty allows it to unfold in a way that doesn't require dramatic leaps. You don't need sudden catastrophes for a civilization to disappear. You only need enough time and enough change. One type of reset people often imagine involves natural disasters, massive volcanic eruptions that transform the climate, asteroids that strike with enough force to darken the sky for years, floods that reshape coastlines entirely. These events have happened many times throughout Earth's history. We can see their signatures in rock layers, in fossil shifts, in sudden declines of species. They're dramatic, but their effects play out over years or centuries rather than minutes. Life changes because conditions change, not because everything ends instantly. A reset like that, if it affected a civilization, would leave little behind. Cities near coasts could vanish under rising seas. Structures on land might collapse under volcanic ash or seismic shifts. Populations might relocate, leaving once flourishing regions empty. Over long enough periods, the land itself could move, submerge, or erode. What remains might be indistinguishable from natural formations. A civilization could fall beneath these forces without needing an end-of-the-world scenario. It would simply lose the stability that allowed it to thrive. Another kind of reset comes from climate shifts. The Earth's climate has cycled between warm periods and ice ages many times. Ice sheets have advanced far enough to bury entire landscapes. Deserts have expanded until once fertile regions became barren. Rainfall patterns have shifted by hundreds of miles. These changes reshape where life can flourish. A civilization arising in one climate could find itself unable to adapt when that climate changes. Even a slow shift can be devastating when survival depends on reliable seasons and consistent resources. These climate-driven resets don't erase the planet. They reshape it. A civilization might retreat, it might fragment, it might survive in smaller pockets, and eventually it might disappear entirely, leaving behind only subtle traces. If that happens millions of years before our time, those traces would blend into sediment, become part of the soil, or dissolve completely. There are also biological resets, periods where species evolve rapidly, periods where extinction rates rise, periods where ecosystems reorganize. These shifts don't require dramatic events. They can result from gradual changes in temperature, ocean chemistry, or atmospheric composition. A species that once thrived might find itself less suited to new conditions. A predator might emerge that disrupts established balance. A disease might spread through populations with no natural immunity. Over long enough spans, even dominant species can vanish entirely. If intelligence were tied to one of those species, its disappearance could be complete. A civilization might decline long before the species itself went extinct, especially if its survival depended on specific materials or environmental stability. And once gone, the memory of its existence would fade. If it left behind little that could fossilize or survive erosion, the record of its time on Earth might be nothing more than a slight disruption in sediment, or a chemical signature no one recognizes as artificial. Reset theories also consider geological activity. The Earth's crust moves constantly. Over millions of years, continents drift across the globe, oceans open and close, mountains rise and fall. Land that once sat at sea level might now be part of a mountain range. Land that once held forests might now lie beneath deep ocean trenches. If a civilization existed on one of these shifting plates, its remains would be subject to forces powerful enough to distort, submerge, or obliterate them. Even the strongest materials would not withstand the effects of subduction or metamorphism. The crust recycles itself, taking whatever sits on its surface into its depths. That kind of reset is slow and steady. It doesn't clear the world in an instant. It simply moves the landscape into forms that make detection impossible. Everything that once stood on the surface becomes part of the deep earth, altered beyond recognition. Some reset theories involve a combination of these factors, not a single event but a sequence. A civilization could rise during a stable climate, expand during a period of abundant resources, and then gradually face increasing challenges. The land might become less fertile. Weather patterns might become unpredictable. Seas might encroach on coastal regions. Natural disasters might occur with greater frequency. Each challenge might weaken the civilization slowly, and eventually it might decline until only scattered groups remain. Over generations, knowledge could be lost, traditions forgotten, languages changed, and the memory of the civilization's peak erased. This kind of reset doesn't require a catastrophe. It only requires enough disruption over enough time. Most civilizations rise and fall this way. Their decline is gradual, marked not by a single moment, but by a long sequence of adjustments until they no longer resemble what they once were. When people talk about great resets in a modern context, they sometimes imagine controlled events, planned reorganizations, or forced shifts. But the resets considered in deep time are different. They're not orchestrated, they're not intentional, they're simply the natural outcome of a planet in motion. Earth is dynamic. It does not preserve its past neatly. It doesn't hold on to landscapes for long. It recycles, erodes, reshapes, and renews. Any civilization living on such a planet is subject to those forces. What makes these resets especially interesting is how subtle they can be. They don't always leave clear markers. They don't always produce obvious layers of destruction. A shift in rainfall patterns might leave a thin layer of mineral deposits. A slow rise in sea level might create a line of sediment that looks no different from ordinary coastal buildup. A prolonged drought might leave slightly different chemical signatures in soil. These traces blend into the natural record until they're indistinguishable from other patterns caused by Earth's changing climate. The soft edges of reset theories remind us that the absence of evidence is not evidence of absence. It simply reflects how difficult it is to detect anything from millions of years ago. The deeper you go into time, the more the Earth has overwritten itself. Even fossils from those periods can be rare. Most living things leave no trace. Most structures collapse before they fossilize. Most chemical signatures dissipate or transform. If an ancient civilization rose in one of these distant eras, its disappearance might look identical to the disappearance of countless ecosystems that came before it. The Earth doesn't keep separate records for natural and artificial changes. It layers them together until the patterns blur. Another aspect of reset theories explores how knowledge behaves. Knowledge can survive longer than structures if it remains embedded in cultural memory. But if populations disperse or shift drastically, that knowledge can fade quickly. Languages change, stories evolve, ideas once understood become symbols, symbols become myths, and myths become puzzles for future generations. A reset doesn't just erase physical remnants, it erases the continuity needed for information to persist. If an ancient civilization possessed knowledge of mathematics, astronomy, or engineering, and if that civilization declined slowly, some of that knowledge might survive in indirect ways. It might influence later cultures in small, untraceable forms. It might reappear as independent discovery. It might become part of stories that no longer resemble the reality that produced them. This possibility adds another layer to reset theories. It raises the question of whether some aspects of human knowledge emerged suddenly, because they were rediscoveries rather than inventions. A culture might have stumbled upon a mathematical relationship that mirrors one known long before. Not because it inherited the idea directly, but because the pattern exists in nature and eventually someone will notice it. If earlier civilizations also noticed these patterns, the knowledge could have cycled through the ages in ways we can't fully track. The soft edges of these theories come from their restraint. They don't claim that resets happened for certain, or that advanced civilizations definitely rose and fell long before humans. They simply recognize how many times the Earth has changed, how many opportunities intelligence might have had, and how thoroughly time can erase any evidence of that intelligence. These theories operate in the space between what we know and what we can't know. They're built on humility rather than certainty. They also remind us that our own civilization is not immune to resets. Climate changes, resources shift, populations move, technologies transform. The world we know today could look entirely different in a few thousand years, and in tens of thousands, it might bear no resemblance to our current one at all. If our civilization faced a decline similar to those imagined in ancient reset theories, much of what we've built could vanish quickly on geological scales. Only small hints might remain, scattered across sediments and rock layers. Future beings studying those traces might find themselves in the same position we're in now, piecing together clues from an incomplete record. Reset theories don't insist that history is cyclical. They simply acknowledge that the planet offers cycles, and civilizations, whenever they arise, are shaped by those cycles. The soft edges keep these ideas grounded. They prevent the conversation from shifting into unfounded speculation. They allow us to explore possibilities without claiming answers that the evidence cannot support. Most people, when they imagine the past, picture it as something waiting just beneath the surface, something that could be uncovered with enough brushing, digging, or careful examination. But the truth is that nature doesn't behave like an archivist. It doesn't store history neatly. It doesn't organise events in tidy layers. It doesn't protect memories for our convenience. Instead, the Earth treats its surface as material meant to be recycled, reshaped, and redistributed. What looks permanent to us is only temporary in the planet's eyes. Soil moves, water carries things away, wind smooths edges until forms lose their meaning. Heat and pressure transform entire landscapes. And through all these processes, whatever once existed can fade so completely that it becomes indistinguishable from everything around it. To understand how nature erases, it helps to look at erosion not as a destructive force, but as part of a continuous exchange. A mountain range might appear immovable and strong, yet every year tiny fragments break away. Those fragments travel down rivers, settle in valleys, or fall into the ocean. Over millions of years, mountain peaks worn by weather become gentle hills. Layers of sediment pile up in places that once had none. Landscapes rotate between being carved and being filled. If a civilization built something on one of those mountains long before humans came along, that structure would have been chipped away bit by bit. Stones would loosen, edges would soften. Eventually nothing recognizable would remain. Water plays an even bigger role. Rivers are like moving blades, cutting through stone with persistence rather than force. They wash away soil, carry debris long distances, and carve canyons. Any structure built too close to a riverbank would eventually fall victim to its shifting path. Even something located well above the water could be worn down by rain. Over time, water seeps into cracks, freezes, expands, and breaks apart whatever stands in its way. This repeated cycle, acting across millions of years, ensures that almost no material survives unchanged. If an ancient society once stood where a modern river now flows, the trace of it would be carried far away, broken down until it became just another component of the riverbed. Coastlines change constantly as well. Waves, tides, and storms reshape shores every day. Beaches expand and shrink. Cliffs crumble. Sand dunes migrate. Over longer timescales, entire coastlines move inland or outward depending on sea levels. A settlement built near the ocean could vanish quickly in geological terms. Rising waters would inundate it. Sand would bury it. Sediments carried by waves would fill the spaces between structures, and in time the evidence would be buried under the seafloor, compressed into new layers of rock. If someone searched for that settlement today, they would not find walls or foundations. They'd find only sediment patterns that look identical to natural formations. Forests and vegetation also contribute to this process. Plants grow through structures with surprising strength. Roots break apart stone, they fill cracks, widen them, and destabilize foundations. When trees fall, they scatter organic material that decomposes and blends with soil. In humid climates, structures made from organic materials decay quickly. Wood becomes soft, fibers disintegrate. Without maintenance, entire buildings can vanish in a matter of decades. Over centuries, forests reclaim everything. Over millennia, those forests disappear too, replaced by new environments that leave behind different traces. The original structures, if any existed, dissolve into the cycle of growth, decay, and regrowth. Even deserts, despite their stillness, are constantly shifting. Wind moves sand into dunes that can bury entire landscapes. These dunes migrate slowly, covering and uncovering areas over long periods. A settlement built in such a region might disappear beneath the layers of wind-blown sand. Once buried, the shifting sands could grind down exposed surfaces until all recognizable features eroded away. What remains might be compacted into sandstone over millions of years. Sandstone, once formed, holds few details. It smooths out whatever was originally there. Ice works differently, but just as effectively. Glaciers carve through landscapes with tremendous pressure, carrying boulders and debris across long distances. They flatten some regions and create deep valleys in others. Underneath a glacier, anything once standing would be crushed, scraped, or transported far away. When the ice melts, the landscape left behind bears little resemblance to what existed before. Layers of till cover everything. Rocks scattered by the glacier create patterns that look intentional, but are entirely natural. Any traces of a previous civilization caught in these movements would be destroyed almost immediately. Given these forces, it's remarkable that anything survives at all. Nature's constant motion ensures that only the most durable or fortunate structures persist over long spans of time. Even then, those structures only survive if the conditions are exceptionally stable. Most of the planet does not offer that stability. Earthquakes shift land suddenly. Volcanoes blanket regions with ash. Landslides bury entire valleys. Tectonic plates push continents together or pull them apart. If a civilization were to rise in one of these unstable zones, its remnants would be scattered or destroyed long before anyone could discover them. But for all the ways nature erases, it also has ways of remembering. These memories aren't preserved intentionally, they're accidental. They occur when conditions align in just the right way to trap a trace of the past. Fossils are one example. They form only under specific conditions. A creature must die in a place where sediment accumulates quickly. Its remains must be buried before scavengers or microbes destroy them. Minerals must seep in to replace organic material. The surrounding layers must remain undisturbed long enough for the fossil to harden. Even then, the fossil might never be found. It could remain buried for millions of years or be destroyed by erosion before anyone sees it. Just as nature preserves bones, it can also preserve structures unintentionally. Volcanic ash can entomb buildings the way it did in certain regions of early human history. Mudslides can bury settlements under layers of soil that harden over time. Lakes can submerge artifacts in oxygen-poor water that slows decay. Peat bogs can preserve wood and even soft materials for surprisingly long periods. But these conditions are rare, and they only operate within certain time frames. Over millions of years, even these preserved items eventually succumb to geological change. A buried object might fossilize, but fossilization alters its structure so completely that its artificial origins might no longer be recognizable. Another form of natural memory involves chemical signatures. Certain industrial activities leave compounds in the environment that may persist long after physical objects disappear. Modern humans, for example, produce pollutants that will remain detectable in sediments for thousands, possibly millions of years. If an ancient civilization used chemicals or produced waste products that altered the environment, faint traces of those compounds might persist in rock layers, but interpreting those signatures is difficult. Nature also produces many of the same elements and compounds. Determining whether a particular spike in a chemical is artificial or natural requires context, and context can be lost easily across deep time. Patterns in sediment can also serve as a kind of natural memory. When a region experiences sudden deforestation, erosion increases, leaving behind distinct layers of soil. When a population expands or farms intensively, the soil composition changes. If a civilization long before ours engaged in large-scale agriculture, mining, or land modification, it might leave behind patterns in the sediment. But once again, distinguishing these patterns from natural shifts is complicated. Floods, fires, storms, and climate cycles can create similar effects. Nature remembers in stone as well. Certain types of rock preserve impressions of what existed before. Footprints in mud can harden into rock. Marks left by tools, if protected from erosion, might become fossilized. But these instances are incredibly rare. The majority of impressions fade long before they have a chance to fossilize. When they do survive, they often become so distorted that interpreting them becomes guesswork. Even the absence of certain materials can be a form of natural memory. A region may contain minerals in patterns that suggest extraction or alteration. But after millions of years, those patterns could just as easily be the result of geological processes. Without clear evidence, it becomes impossible to determine whether the changes were intentional or natural. Despite nature's thoroughness in erasing, it sometimes preserves hints of ancient environments. For example, scientists can look at pollen trapped in layers of sediment to understand what kinds of plants once grew in a region. They can study trapped air bubbles in ice cores to determine ancient atmospheric conditions. They can analyze tree rings to understand climate shifts. These memories allow us to piece together the world's past, but they only reach back a few 100,000 years at most. Beyond that, the record becomes fragmented. The deeper we look, the fewer details remain. If a civilization existed millions of years ago, nature's ability to remember would almost be too faint to detect. The geological record from those eras is far less complete. Entire continents from that time have shifted beyond recognition. Mountain ranges have risen and disappeared. Oceans have covered regions that are now land. Fossil records are sparse and often incomplete. Even the best preserved layers contain only fragments of ecosystems. If anything artificial existed in those periods, the odds that it survived in a recognizable form are incredibly small. But even if physical traces don't survive, there might be indirect signs. Climate shifts with no obvious cause, unusual concentrations of certain elements, sediment layers that indicate sudden changes in land use. These would not be obvious markers. They would be subtle, ambiguous, and open to multiple interpretations. And that ambiguity is perhaps the most important aspect of nature's accidental memory. It doesn't preserve stories, it preserves hints. Those hints require careful reading, thoughtful interpretation, and a willingness to accept uncertainty. Even in more recent times, we see how fragile the record is. Some human civilizations left behind almost nothing. Entire cultures are known only through a handful of artifacts or structures, and those artifacts only survived because they were made of materials strong enough to withstand centuries. Many societies used organic materials that vanished completely. Their stories, traditions, and discoveries are lost, remembered only through the influence they had on later groups. If that can happen within a few thousand years, then the idea that entire civilizations could disappear without a trace over millions of years is not far-fetched. Nature erases because its processes are relentless. Rain falls, wind blows, tectonic plates clash, oceans rise and fall, The surface of the Earth is constantly moving, adjusting and renewing. But in rare moments, nature remembers, not in full narratives, but in fragments. A fossil here, a chemical signature there, a layer of sediment that hints at a distant event. These accidental memories are all we have to understand the world before our own. They show us that while the past is mostly hidden, it isn't entirely gone. There are moments in human history that feel uncannily familiar, even when they take place thousands of years apart. Patterns repeat themselves in ways that make it seem as if we're walking along an old path rather than forging a new one. You can see these patterns in the rise and fall of societies, in the inventions that seem to appear simultaneously across different regions, and even in the myths that cultures develop without any contact between them. This repeating quality creates the sense that humanity is not moving in a straight line, but circling around ideas and behaviours that have surfaced before. Some people describe this sensation as a form of deja vu, not in the neurological sense where the brain misfires and mistakes the present for the past, but in a broader cultural sense. It's as if certain themes are woven into human nature so deeply that they re-emerge whenever conditions allow. This reappearance doesn't require knowledge from earlier societies, it can happen entirely independently. But its consistency makes you wonder whether intelligence naturally gravitates toward the same solutions and the same stories, no matter where or when it arises. One of the clearest examples of this repeating pattern comes from early architecture. Without communication, societies across vast distances built structures based on similar principles. They used pyramids, terraces, circular enclosures, and aligned buildings with the movements of the sun and stars. These similarities don't imply direct connection. They simply reflect the fact that people facing similar challenges often come to similar conclusions. A pyramid, for example, is a stable shape that supports weight efficiently. Terracing prevents erosion on slopes. Aligning structures with the sun helps track seasons. These solutions emerge naturally when societies grow large enough to need them. Still, the similarities can feel striking. People who lived oceans apart, separated by thousands of years, created systems that echo one another closely. This sense of recognition extends beyond architecture. Writing systems developed independently in different parts of the world, yet they share certain patterns. Early forms of mathematics, despite being created by unrelated cultures, include comparable ideas about counting, geometry, and measurement. Even early legal systems built to solve disputes in growing communities contain rules that resemble one another. These parallels suggest that intelligence, when given time and stability, follows certain pathways. It's not that one culture taught another, it's that the constraints of the world guide development in ways that lead to similar outcomes. If an intelligent species existed long before humans and faced similar environmental pressures, it might have developed tools, structures, and systems that resemble those we later built. We wouldn't find their artifacts, but we might feel their echo in the way we ourselves solve problems. There's also a sense of déjà vu in the way civilizations rise and fall. The pattern of growth, expansion, imbalance, and decline appears repeatedly across history. A small community grows, develops systems to manage resources, expands its influence, and eventually becomes strained by its own complexity. Changes in climate, resource distribution, or internal stability can push it toward decline. This rhythm isn't unique to humans, it reflects the dynamics of systems in general. Complexity requires energy. When energy becomes scarce or inefficiently managed, systems simplify or collapse. That pattern could shape any civilization, regardless of species or time period. Even myths reflect unusual consistency. Stories about floods appear across cultures, even those separated by vast stretches of time and geography. Myths about earlier ages of the world, often described as times when beings had extraordinary abilities or lived closer to the gods, also appear widely. These stories may reflect collective memory of real events. sea level rise, asteroid impacts, volcanic eruptions, or they may symbolize transitions between eras. But their repetition is striking. People who had no contact told similar stories, as if they were recalling something universal. Language exhibits this tendency as well. Certain grammatical structures appear naturally in unrelated language families. The evolution of languages follows predictable paths. Even the way people think tends to converge around certain frameworks. This doesn't mean we're remembering specific events. It means intelligence responds to the world in patterned ways. But if intelligence has arisen more than once on Earth, these patterns might echo more deeply than we realize. It's possible that some ideas repeat not because they're universal, but because they were discovered before and resurfaced in new forms. There's another layer to this sense of repetition found in technological leaps. Throughout history, innovations appear in clusters. One culture invents something, and another culture, without contact, invents a nearly identical concept around the same time. Agriculture emerged independently in multiple regions. Writing did the same. Metallurgy arose in different areas with only loose or indirect connections. This synchrony suggests that certain advancements become inevitable once societies reach particular stages. If a civilization long before humans reached similar developmental thresholds, it might have followed comparable patterns. Even if nothing physical remained from that earlier civilization, the ideas humans later discovered might mirror those earlier patterns simply because they represent common solutions to recurring challenges. In that sense, humanity could be reenacting certain stages of development without ever knowing it. Some researchers point to ancient myths that describe cyclical ages, golden ages, declines, renewals, and resets. These cycles are symbolic, but they might also reflect observations about the world passed down through generations. When you consider how often the Earth's climate has shifted, how many times sea levels have risen or fallen, and how frequently ecosystems have transformed, it's understandable that ancient cultures would interpret these changes as recurring ages. Interestingly, even modern people experience a kind of déjà vu when studying ancient artifacts. Certain designs, patterns, or techniques feel familiar, not because we've seen them before, but because they resonate with how we might solve problems today. A tool carved thousands of years ago might resemble one we'd intuitively create if faced with the same challenge. A piece of art might reflect shapes or ideas that feel natural. This familiarity hints at underlying cognitive tendencies shared across time. There are also the moments when humanity rediscovers knowledge once believed lost. Architectural techniques reappear in later civilizations after vanishing for centuries. Medical practices that disappeared in one region re-emerge independently in another. Navigation methods once thought forgotten resurface, when new explorers face similar challenges. These rediscoveries suggest that ideas can return even without direct transmission. Humans repeatedly solve the same problems because the problems themselves remain constant. This creates an intriguing possibility. If a civilization existed long before humans, certain insights they discovered might later reappear in different forms, not because their knowledge was directly passed down, but because intelligence naturally gravitates towards certain ideas. What feels like ancient déjà vu might be the echo of pathways taken before. It doesn't require evidence of earlier civilizations. It only requires accepting that intelligence is shaped by the same physical and environmental constraints across time. Still, some aspects of human development feel strangely advanced for their context. Certain early cultures demonstrated knowledge of celestial cycles that require long-term observation. Others used mathematical systems that appear more sophisticated than expected. These leaps forward could reflect exceptional individuals, unique environmental conditions, or long traditions of observation. But it's also possible that some of these insights represent rediscoveries of ideas once known long ago, echoing faintly through the patterns of human thought. The sense of déjà vu extends into art as well. Symbolic shapes, repeated motifs, and recurring themes appear in cultures separated by time and geography. Spirals, circles, and geometric patterns show up repeatedly. These shapes might arise naturally from the way humans perceive the world. They might reflect neurological tendencies or mathematical relationships found in nature. But the repetition creates a feeling of recognition. It's as if certain artistic ideas are waiting in the background of human consciousness, ready to emerge whenever people begin exploring abstract concepts. Even philosophical ideas reflect this repetition. Concepts about the nature of existence, the cycles of life, and the structure of the universe appear in multiple cultures independently. Theories about parallel worlds, hidden layers of reality, or recurring ages are not modern inventions. They've appeared in human thought for thousands of years. These ideas might reflect universal questions that intelligent beings ask when contemplating their place in the world, but they might also be distant echoes of perspectives explored in earlier cycles of thought. It's worth noting that societies sometimes develop nostalgia for eras they never lived through. They imagine ancestral ages filled with wisdom or harmony. They tell stories about lost knowledge, forgotten technologies, or ancient powers. These stories reveal a deep human feeling that the present is not the peak of time, but one point in a larger sequence. Whether that feeling arises from cultural memory, pattern recognition, or something older, it contributes to the sense that we're participating in something that has unfolded before. On a smaller scale, individuals experience deja vu when learning new skills. Someone picking up a tool for the first time might use it instinctively. A person encountering a new concept might grasp it quickly. These moments could reflect natural cognitive abilities, but they also show how humans carry underlying frameworks that guide thought and behaviour. If earlier intelligent species existed, and if their development followed similar patterns, human abilities might reflect deeper evolutionary tendencies shaped by environments that have repeated across time. When researchers study cumulative cultural evolution, the way knowledge builds over generations, they discover that ideas rarely disappear completely. They might fade, transform, or shrink to myth, but fragments linger. Those fragments can influence future developments. If something similar happened many cycles ago, the distant memory of earlier civilizations wouldn't remain in stories or artifacts. It would remain as patterns of thought, ways of organizing information, or intuitions shared across species. This possibility highlights how interconnected development can be, even without direct transmission. If intelligence follows predictable paths, then civilizations arising millions of years apart could experience strikingly similar stages. Humanity's sense of déjà vu might reflect this deeper continuity, not because we remember specific events, but because the structures of the world guide the evolution of ideas. The concept of inventions appearing independently supports this. People who have never met often arrive at the same innovations around the same time, because societal pressures push them in similar directions. Agriculture, metallurgy, writing, navigation, and mathematical reasoning emerged in parallel. If an earlier civilization once developed these ideas, humanity might be walking along similar routes without even knowing it. The route itself is shaped by the world, not by memory. Another aspect of this déjà vu arises when people encounter ancient ruins. They stand in silence before structures built thousands of years ago and feel a sense of familiarity. Something about the proportions, the layout, or the craftsmanship resonates. It isn't because they've seen these structures before, it's because the human brain responds in predictable ways to symmetry, balance, and order. If earlier civilizations used similar principles, their creations might evoke the same feeling, even if nothing remains today. Some thinkers have suggested that déjà vu could represent the brain processing information from multiple perspectives at once. But on a cultural level, déjà vu reflects a deeper observation. Different societies often discover similar truths because the underlying reality hasn't changed. The Earth remains the same planet with the same patterns, the same cycles, the same challenges. Intelligence, whenever it appears, must navigate those patterns. The results will naturally resemble one another. This perspective doesn't require that earlier civilizations existed, It simply acknowledges that if they had existed, their development might feel familiar to us because we're responding to the same world. Humanity's strange deja vu could then be seen as the echo of paths taken before, not in the sense of memories carried through time, but in the sense of repetition shaped by the planet itself. Daily life gives the impression of steady movement forward. You wake up, follow familiar routines, make decisions that seem unique to each moment, and assume the world is progressing in a straight line. But when you step back far enough, the idea of linear progress begins to look more like a comforting illusion than the true shape of things. Many aspects of human experience repeat themselves without people noticing the repetition. These cycles can be subtle, unfolding slowly over generations, or they can be broad, shaping entire eras. And because they move quietly, most people don't realize they're participating in them until long after the cycle has completed its arc. One of the most obvious examples shows up in the growth of societies. As communities expand, they face challenges that appear unique but are actually familiar. Resource management becomes difficult. Conflicts increase. Infrastructure becomes strained. These pressures push leaders to develop new systems, strengthen old ones, or reorganize the structure of society. As populations grow, the demand for efficiency rises. This pattern mirrors itself across continents and across time. Each society believes it is confronting unprecedented issues, but the challenges often resemble those faced by civilizations long before. Even technological development follows recognizable loops. The inventions that change the world, from tools to agricultural systems to industrial machines, emerge during periods of need, flourish, then become so integrated into daily life that people forget they're part of a cycle. After a period of stability, new challenges appear and societies seek innovations once again. This rhythm continues no matter how advanced a society becomes. It's not a straight progression, but an oscillation between stability and adaptation. Human behavior shows cycles as well. Periods of exploration, when people look outward, seek new land, or push into unfamiliar territory, tend to follow periods of consolidation, when communities settle, refine their knowledge, and become inwardly focused. This pattern doesn't require conscious planning. It emerges naturally from the balance between curiosity and comfort, between the desire to expand and the desire to maintain what already exists. Even the spread of ideas follows predictable patterns. A new ideology or cultural movement arises, grows, influences society, then fades, only for a similar idea to appear in a later era under a new name. These repetitions aren't accidental. They reflect the underlying needs of people living through different stages of societal change. Challenges return, and when they do, the ideas that once offered solutions return as well, dressed in the language of the current time. Cycles affect the natural world in ways that influence human behavior. Climate patterns shift slowly but consistently. Rainfall increases and decreases across regions. Temperatures rise and fall over centuries. These environmental changes push societies toward expansion or retreat, depending on their timing. A period of abundant resources can lead to growth. A period of scarcity can lead to decline. When these conditions shift again, the cycle repeats. Because the cycles unfold slowly, it's easy not to notice them. People live too briefly to see the full arc. They experience only a portion of the pattern and assume that portion represents a beginning or an end rather than a middle. This limited perspective makes history feel like a line rather than a loop. But when researchers examine long-term trends, the loops reveal themselves. Another type of cycle appears in ecosystems. Species expand, reach stability, overpopulate, decline, and stabilize again. This happens whether or not humans are involved. It's a natural rhythm of life. When humans influence ecosystems by farming, building, or altering landscapes, they become part of those cycles as well. They don't control them, they participate in them, and when ecosystems shift in response to human activity, the changes can push societies into new cycles they didn't anticipate. Economic systems also demonstrate cyclical behaviour. Periods of growth give way to periods of contraction. Stability turns into volatility. Innovations reshape industries, which then settle into new patterns until the next shift occurs. These economic cycles appear consistently across different regions and eras, suggesting they're not the result of any single decision, but the natural outcome of how humans use resources, create markets, and respond to change. A subtle but important cycle occurs in cultural memory. People tend to forget the lessons of the past after enough time has passed. New generations grow up without direct experience of events that shaped earlier ones. They repeat certain behaviours not out of ignorance, but because the connection between past and present weakens over time. This forgetting is part of the cycle. Old mistakes return. Old insights return as well. They reappear not because people deliberately revive them, but because the environments that produced them re-emerge. This cycle of forgetting and rediscovery influences the development of knowledge. Scientific understanding doesn't simply accumulate linearly. It moves forward, stalls, regresses in certain areas, and then leaps ahead. Ideas once explored may be set aside for centuries before resurfacing in new ways. Techniques from early societies sometimes reappear in modern times after rediscovery, simply because they solve a problem that has cycled back into relevance. If intelligence has arisen more than once on Earth, it's possible that earlier civilizations experienced similar cycles. They might have developed complex societies, faced environmental challenges, adapted, grown, and eventually declined. Their ideas might have been lost completely, or might have resurfaced indirectly in the way human societies later evolved. If so, humanity might not be the first to follow these loops. We might simply be experiencing the same arc that earlier civilizations experienced, shaped by the same conditions and constraints. This idea doesn't require direct inheritance. It only requires acknowledging that cycles are built into the structure of the world. When intelligence interacts with the environment, certain patterns of behavior emerge naturally. Those patterns create loops in development, culture, technology, and organization. The loops might differ in detail but remain consistent in shape. Some cycles take place on scales so large that no individual generation could ever perceive them. For example, geological cycles operate across millions of years. Continents drift apart, collide, drift apart again. Oceans open and close. Mountain ranges rise and erode. These cycles influence climate, sea levels, and available resources. A civilization arising during one phase of a geological cycle might prosper because the environment is mild and stable. Another civilization rising during a different phase might face harsh conditions that limit its development. If earlier civilizations existed during different phases of these long cycles, their experiences would differ from ours in significant ways. Their rise might have been accelerated or hindered by climates we've never known. Their decline might have been shaped by geological events we haven't experienced. From our perspective, these cycles would be invisible, but they might have determined the fate of civilizations long before humans. Another long-term cycle involves biodiversity. Life on Earth has gone through multiple expansions and extinctions. After each extinction, new species arise to fill the empty niches. Sometimes evolution takes familiar forms. Certain body shapes, feeding strategies, and evolutionary strategies appear repeatedly because they are efficient. If intelligence evolved multiple times, it might follow a similar pattern. The details of each species would differ, but the cognitive traits required for civilization, problem-solving, communication, tool use, would emerge again and again in similar configurations. These biological cycles help explain why humans might experience certain instincts, behaviors, or preferences that feel older than humanity itself. Some capabilities might be deeply rooted in evolutionary patterns that have repeated across earlier cycles of life. If intelligence is a recurring outcome of evolution, then humanity's tendencies might reflect a long chain of iterations rather than a single point of origin. Cycles also exist in how species use energy. Early humans burned wood, later used coal, and eventually developed more complex sources of power. Each step reflects a shift in available resources and technological ability. If earlier civilizations once existed, their energy cycles might have followed similar paths. They might have started with biological energy, then moved to more efficient sources, and eventually encountered limitations that forced them to adapt or decline. These patterns are visible today. Humans use energy sources until they become scarce or environmentally damaging. Then they search for alternatives. This search often mirrors earlier stages of development, creating a loop where old ideas resurface in new contexts. If earlier civilizations faced similar challenges, the same cycle might have unfolded long before humans existed. Another cycle emerges in how societies respond to uncertainty. When people face periods of instability, they often turn to tradition, authority, or familiar structures. When stability returns, they become more open to new ideas and experimentation. This shift affects politics, religion, art, and science. Over time, societies oscillate between periods of conservatism and periods of innovation. These oscillations appear across cultures and eras, suggesting they are deeply rooted in human nature. And if intelligence evolves similarly across species, these cycles might be universal. Even the belief in cycles itself is part of a cycle. People become interested in the idea during times of uncertainty. They look for patterns that explain the chaos around them. When stability returns, interest fades, only to return again during the next period of upheaval. This repeating focus on cycles reflects our desire to find meaning in change. It suggests that humans are instinctively drawn to the idea that the world moves in loops rather than lines. The most subtle cycles are the ones individuals experience internally. People revisit old habits, return to familiar places, or repeat decisions they thought they'd moved past. This personal repetition mirrors the larger cycles of society. It's a reflection of how the brain processes information, stores memories, and navigates the world. And these internal cycles can influence large-scale behavior when enough individuals participate in them. When we consider how many cycles shape our lives, it becomes easier to imagine that humanity might be part of a much larger sequence. If civilizations have risen before, they might have experienced similar loops. They might have built societies that expanded, confronted familiar challenges, adapted for a time, and eventually declined. If the world continues for millions of years more, future civilizations might repeat the same arcs. Recognizing these cycles doesn't diminish human achievement. It gives context. It helps explain why certain developments feel inevitable, why certain failures recur, and why progress never feels as linear as textbooks describe. It also encourages humility. If we are part of a cycle, then our place in history is one stage among many. Not a beginning, not an end, just one turn in a repeating pattern shaped by the planet itself. Imagining another intelligent species that lived long before humans requires setting aside familiar assumptions. Not because the idea is impossible, but because our picture of intelligence is shaped entirely by what we see in ourselves. We tend to imagine earlier civilizations as versions of humanity placed far back in time. That approach narrows the possibilities so much that it becomes difficult to think beyond simple parallels. A more helpful way to explore this question is to consider the full range of what intelligence could look like under conditions very different from those we know. The starting point is acknowledging that intelligence doesn't automatically produce the same outcomes across species. It doesn't require cities, metal tools, or the kind of technology humans create. Intelligence might take forms suited to environments that leave behind almost no durable trace. A species living in dense forests, wetlands, or coastal regions could develop complex problem-solving skills, create social structures, and even manipulate their environment without ever shaping materials that fossilize well. Their existence might blend into the natural world, disappearing completely when landscapes shift. Another possibility is that an earlier civilization wasn't technologically focused at all. Technology, as humans define it, relies heavily on modifying the environment to suit our needs, but intelligence could develop in a species that adapted itself to the environment instead, using biological strategies rather than external tools. Such a species might have advanced communication, shared knowledge, and cultural traditions but leave behind no manufactured objects. Their traces could resemble ordinary biological remains, indistinguishable from other species of their time. It's worth considering the possibility that an ancient intelligent species might have been much smaller or larger than humans, altering what they were physically capable of building. A smaller species might create intricate structures out of materials that cannot survive long term, something akin to what bees or termites do today, except guided by higher cognition rather than instinct. A larger species might favour open spaces, avoid enclosed structures, or use natural formations rather than building anything artificial. In either case, the remnants would not resemble human ruins. They might appear natural even when examined closely. Species that evolved intelligence in aquatic environments introduce another branch of possibilities. Oceans hold more secrecy than land. Life beneath the surface decays differently. Structures built underwater erode quickly. Organic material dissolves or is consumed. Minerals shift with the currents. Even large constructions could break apart within centuries and leave no identifiable remnants. If an intelligent species lived primarily in the ocean millions of years ago, their entire civilization could vanish without a trace, except for subtle disruptions in sediment or faint chemical signatures. The ocean is a place where nature's erasing process is even more efficient than on land. Some scientists point out that octopuses already display remarkable intelligence, creativity, and problem-solving skills despite having evolved separately from mammals. Their ancestors stretch far back into deep time. If a lineage like theirs had evolved higher intelligence during a stable period in the distant past, it's not unreasonable to imagine an aquatic civilization that rose and fell long before humans existed. Such a species could have developed methods of interaction and organization completely different from ours. Their tools might have been temporary or biological. Their communication might have relied on color, sound, or chemical signals. Nothing in that system would leave behind recognizable artifacts. Another question to consider is whether an earlier intelligent species would have lived during a time when the planet's climate and geography were dramatically different. Vast regions that are now covered by ocean could once have been exposed land. Areas now occupied by mountain ranges could have been gentle plains. If a civilization flourished in one of these lost landscapes, the physical evidence might lie beneath thousands of meters of sediment, subducted beneath tectonic plates, or transformed into metamorphic rock. Even something the size of a modern city could vanish completely under those conditions. There's also the possibility that intelligence arose during one of Earth's warmer periods, when tropical climates extended into regions that are now temperate. In such environments, organic materials decay more quickly. Wood, fibers, and plants break down rapidly. Structures built with those materials wouldn't survive even a few thousand years, let alone millions. Fossils from these regions are rare because heat and humidity accelerate decomposition. If an earlier civilization relied on organic construction methods, their remains would simply not persist. Thinking about who they were becomes even more complex when you consider how evolution works across long timescales. Intelligence rarely appears suddenly. It tends to emerge in species facing unique pressures, environmental instability, the need for cooperation, predators that force innovation, or resource scarcity that encourages problem solving. The shape of the species depends on the ecological niche they inhabited. Their behaviours reflect the challenges they faced, and their civilization, if they built one, would reflect their biology. For example, a species with excellent night vision might develop cultural practices centered around darkness. A species with heightened sensitivity to magnetic fields might navigate the world differently, building their society around patterns humans cannot detect. A species with underwater echolocation might communicate in ways that leave no written record. Even the appearance of their dwellings might resemble coral formations or burrows, rather than anything humans recognize as construction. If they communicated through complex sound patterns or chemical signals, their cultural memory would have been stored in ways that do not fossilize. They might have passed knowledge through behavior rather than writing, through shared rituals rather than physical records. The absence of inscriptions or symbols doesn't rule out intelligence, it only reflects the limitations of what we can recover. Another avenue of thought explores the idea that an earlier civilization might not have been widespread. Human civilization covers the globe today, but that's a recent development. For most of human existence, populations were localized. If an earlier species developed intelligence in a limited region, a valley, island chain, coastline, or river basin, their civilization could fade without influencing distant ecosystems. Localized civilizations leave fewer traces. Once their environment shifts or disappears, the evidence vanishes with it. Some researchers wonder whether intelligence could have arisen in species we already know, but mistakenly assume were incapable of it. Fossils preserve bones, not behavior. A species might appear primitive in structure, but have developed unexpectedly complex social systems, communication methods, or cognitive abilities. Without clear behavioral evidence, we can't rule out the possibility that intelligence once emerged in species that left no trace of their mental capabilities. It's also possible that intelligence emerged in a species we have yet to discover. The fossil record is incomplete, especially for earlier eras. Entire species remain unknown because their remains were never fossilized or have not yet been found. Geological processes erase more fossils than they preserve. If an intelligent species lived in dense forests, wetlands, or tropical regions, the odds of their remains fossilizing are extremely low. The fossil record gives us glimpses, not complete pictures. There's also the matter of technological development itself. Humans tend to associate intelligence with industrial progress, but that association is limited to our own experience. A species might reach a high level of cognitive ability without ever developing metalworking or large-scale construction. They might rely on renewable resources, use tools only briefly, or avoid altering their environment extensively. Their impact would blend into natural patterns, leaving behind no clear markers of civilization. A species with advanced biology might have developed ways to manipulate ecosystems subtly, rather than altering them dramatically. Their technology might rely on biological adaptation, cooperative behavior, or environmental management indistinguishable from natural processes. Their innovations could be stored in genes, social structures, or ephemeral materials that don't survive geological time. In that case, the only evidence of their existence would be evolutionary footprints too subtle to identify. Another possibility is that an earlier civilization reached a point of development that didn't require building permanent structures. Humans build houses, cities, and machines because our bodies need protection and our minds seek organization. But another species might have approached life differently. They might have valued mobility, impermanence, or integration with natural landscapes. Their creations might have been temporary by design, intended to be dismantled or decay naturally. It's equally plausible that an ancient civilization achieved technological advances that did not rely on the same materials humans use. Perhaps they developed energy sources or tools that leave behind no long-term trace. Perhaps they used materials that degrade entirely. Perhaps their most powerful achievements involved knowledge, not objects. A civilization can be advanced without leaving behind monuments or machines. Knowledge itself can be the pinnacle of development. When exploring possibilities like these, it's helpful to recognize that our assumptions limit the range of answers. We expect an intelligent species to resemble us in some way. That expectation shapes the search for evidence. If earlier civilizations used different materials, structures, or methods, We might overlook their traces because they don't match our definitions of what a civilization should leave behind. Scientific caution also influences how we interpret anomalies in the geological or archaeological record. Anything that doesn't match established understanding is examined carefully, often assumed to have natural explanations. Most of the time, this approach is correct. Natural processes can produce shapes, patterns, and traces that mimic artificial origins. But this caution means that hints of ancient intelligence, if subtle enough, could be passed over without notice. Researchers are trained to avoid extraordinary conclusions unless supported by extraordinary evidence. Over millions of years, extraordinary evidence is unlikely to survive. Still, the question remains, if we are not the first, then who were they? The simplest answer is that they could have been many different things: aquatic, terrestrial, large, small, tool-focused, biology-focused, permanent, migratory, or something in between. They might have existed briefly or for millions of years. They might have flourished in an era barely represented in the fossil record. They might have disappeared gradually, long before humans evolved. Their world could have been stable or volatile, peaceful or challenging. Their existence, if real, would reflect the same combination of environmental opportunity and evolutionary chance that produced us. Speculating about such a species doesn't require imagining anything extraordinary. It only requires acknowledging that Earth is old enough, dynamic enough, and complex enough to allow for multiple cycles of intelligence. If we consider the planet's full timeline, humanity occupies only a thin layer near the surface. Many layers lie beneath us, each containing stories we can only guess at. There comes a point when following thoughts about earlier civilizations and the possibility of forgotten worlds, where the focus naturally shifts back toward the present. Not in a dramatic turn or a sudden realization, but in a gradual way, as if the questions about ancient cycles slowly reveal something about where humanity stands right now. When you look at our timeline from a wide enough distance, it becomes clear that we're positioned in a place not unlike the one we imagine for any hypothetical species that might have come before us. We're living at a moment where much is known, much is still unknown, and the boundaries between the past and future feel thinner than we usually acknowledge. While it's tempting to think of ourselves as standing firmly in the middle of history, with countless ages behind us and endless possibilities ahead, the truth is that we don't actually know where we fall within Earth's deeper rhythms. What feels like the beginning might be closer to the end of something. What feels like the end might be closer to the beginning of a different stage. Timelines at this scale don't provide markers or labels. They stretch out in both directions without telling us how much has happened already or how much remains. If you look at humanity's progress from a smaller perspective, it seems incredibly fast. The shift from scattered groups of early humans to complex global societies happened in a blink when compared with geological or evolutionary time. Agriculture, writing, industry and technology all developed within a small slice of Earth's history. So small that if you compressed the entire timeline into a single calendar year, everything humans consider civilization would exist only in the last seconds before midnight on December 31st. This gives the impression that we're arriving late to a long-running sequence rather than starting something entirely new. Yet even with this speed, it's not clear how long our moment will last. Civilizations in the past, the ones we know about, rarely recognized when they were nearing a turning point. They continued their routines, expanded their systems, and made decisions for the future without realizing the conditions around them were shifting. Change arrived slowly enough that it didn't feel like change. It felt like continuity. Only in hindsight does the arc become obvious. Looking at our own time, we see patterns that resemble those earlier arcs in subtle ways. Humanity has grown, expanded, overcome challenges, adapted technologies, and shaped the environment in ways that were once unimaginable. But the same growth has created pressures that mirror those faced by earlier civilizations, resource limitations, climate fluctuations, social tensions, and the strain that comes from maintaining complex systems. These challenges don't necessarily point toward decline. They simply highlight the fact that we're part of a larger cycle, and cycles always involve turning points of some kind. Standing at the edge of our own timeline means acknowledging both movement and uncertainty. It means accepting that we might not see the full path ahead or behind. It means understanding that the present moment is not a fixed point, but a continuation of countless previous shifts, many of which are now forgotten. The idea isn't meant to be unsettling, it's meant to bring perspective. It reminds us that our place in history is fluid, shaped by forces much larger than any individual event. Another way to think about this edge is to consider what future beings, whether human or something else, might see when they look back at us. They wouldn't see every detail of our world. They would see patterns. They would see changes in climate, the rise of industry, the spread of cities, and perhaps a few traces of the technologies we now use. They might find chemical layers that indicate our impact on the planet. They might find remnants of structures that manage to withstand time. But much of what we value, our culture, art, stories, beliefs, would be lost unless carried forward in ways that survive beyond material form. This perspective highlights how fragile the memory of a civilization can be. It doesn't take catastrophe or sudden collapse to erase most of what we build. Time itself does the work, slowly and thoroughly. Even a stable civilization can leave behind surprisingly little after a few million years. If earlier intelligent species lived and vanished without leaving clear signs, it wouldn't necessarily mean their existence was insignificant. It could mean that time simply moved forward until the details dissolved. At the same time, being at the edge of a timeline also means having the ability to look both ways. We can reflect on how life has transformed the planet for billions of years, and we can project into the future, imagining how our choices might shape what comes next. This dual perspective is unique. It gives us the ability to understand cycles even while living inside one. It allows us to observe patterns that earlier species might never have recognized, simply because they didn't have the historical data or global awareness we now possess. Yet despite this knowledge, we face the same limitations they might have faced. Our understanding is incomplete. We can analyze sediment, climate records, and geological shifts, but we can't see the full arc of the future. We can model possibilities, but we can't know which path the world will take. We can predict cycles, but we can't control them entirely. The edge of a timeline is a place where insight meets uncertainty, where understanding meets the unknown. There's another layer to this thought, one that relates to how we interpret history itself. When researchers examine the remains of ancient civilizations, they often try to understand them within the framework of their time. But those frameworks are incomplete. The stories we tell about the past rely on fragments, stones, bones, pottery, and traces of writing. The emotional world of those civilizations, their daily thoughts, their fears, their moments of comfort, and their sense of the future can only be guessed at. If an earlier civilization existed millions of years ago, its emotional world would be even more difficult to imagine. Its values, motivations, traditions, and experiences would be inaccessible to us. We might search for signs of logic or structure, but the specifics would be lost. This distance reminds us that even our own civilization, with all its documentation, could one day be interpreted through fragments that don't reflect our full reality. Standing at the edge of our timeline means accepting that our identity is temporary. It doesn't diminish our existence, it highlights it. Just as earlier civilizations may have shaped their time without knowing how brief their moment would be, we are shaping ours. We make discoveries, share knowledge, solve problems, and build systems that feel permanent, even though we know intellectually that nothing on Earth remains unchanged forever. The edge is not a place of endings. It's a place of transition. It's where one cycle gradually makes space for another. These transitions aren't always visible from the inside. They can look like ordinary life, They can feel like steady routine. Only from a distant perspective do they become clear. For humanity, this means we may be living at a moment that future beings will see as a turning point, even if it feels like everyday continuity to us. Thinking this way doesn't require pessimism. It simply acknowledges reality. Civilizations don't last forever. Species don't last forever. Even continents change shape. The importance of the present lies not in its permanence, but in the choices made within it. If we are in fact at the edge of a timeline, whether it's the beginning of decline, the start of renewal, or simply another turn in a long sequence, then our role is to navigate the moment with awareness. Awareness doesn't mean predicting the future. It means understanding the scales involved. Human lifetimes are short compared to geological cycles. Civilizations rise and fall across centuries, but the planet changes across millions of years. If earlier intelligent species lived during those long cycles, then their entire civilizations might have existed and vanished in sections of time that leave behind only minimal evidence. From our vantage point, their existence would look like a blank space, even though to them their time would have felt rich, complex, and full of meaning. This reflection offers a kind of quiet clarity. It suggests that every civilization, ours included, sees itself as central because it experiences only its own moment. But when placed within deep time, that moment becomes one part of a much larger pattern. Not insignificant, but not unique either. Just one unfolding among many. At the same time, standing at the edge of a timeline gives humanity an unusual opportunity. Unlike earlier species, we have the means to record information in durable ways. We have tools for analysing the distant past and projecting the distant future. We have technology that could preserve certain aspects of our knowledge long after structures fade. Whether these efforts will succeed across geological time is uncertain, but the attempt itself reflects humanity's awareness of where we stand. This awareness also invites a different question. If earlier civilizations existed, did they recognize their own place in time? Did they sense the cycles around them? Did they attempt to leave behind traces that might survive beyond their era? Or did they live entirely within their moment, content with the present, unaware of how quickly time would move past them? It's impossible to know, but imagining these possibilities helps illuminate our own position. It shows how fragile memory can be and how important it is to understand the dynamics of the world we live in. It suggests that our moment, brief as it may be, carries within it the potential to influence what comes next. And finally, standing at this edge encourages a kind of calm reflection. Not fear of disappearance, not urgency in the face of uncertainty, but a quiet recognition that being part of a cycle is natural. That living in a world shaped by forces larger than ourselves is part of the human experience. That the timeline we inhabit stretches far behind us and far ahead, with room for countless stories beyond our own.